Hello, everyone, and welcome to Databricks Fundamentals Bootcamp, day 2 of the course. I'm Joan. I'll be your facilitator for today. We welcome you back to the course. And before I hand it over to Mohit to get us started, just a quick reminder that the session is being recorded and that recording will be mailed to you within 24 to 48 hours. Also, want to remind you to please not put any private information in the chat. At the end of today's course, you will see a survey populate. We'd greatly appreciate it if you take a few minutes to complete it before logging off today's session. We do value your feedback. And with that, I'm going to hand things over to Moet to get us started. Over to you, Moet.
Hey, thank you, Joan. And thank you, everyone, for joining the second day of Databricks Fundamentals Bootcamp. I can see a lot of people are here. So once again, welcome. So I think it's time for us to get started. Before that, once again, quick introduction about me. My name is Mohit Batra. I'm founder at Crystal Talks, and we are into content development, training, and consultancy. I'm also an author, so I do publish a lot of video content, including on O'Reilly platform, so you can go and check it out. Plus, I'm a Microsoft certified trainer, and prior to working full-time into training and consultancy, I worked with companies like Microsoft and Saxo Bank. My LinkedIn profile is there on your screen. So in case you wish to have a look or in case you wish to get in touch, I'll be more than happy to connect with all of you. All right. So with that, let's, once again, look at, what we have in our learning objectives. I hope you had a good time yesterday learning about, what exactly do we have in Databricks? How do we set up the environment? How do we navigate through it? And what are the different AI features which are available in Databricks platform? So we briefly talked about that. Then we also looked into Apache Spark. What exactly is Apache Spark? What is its architecture? How does distributed data processing works? And then we also started looking into how we can start or how we can basically build ETL pipelines using Databricks. So this is where we saw that how we can read the data, what exactly are DB utils, how we read the data, how we analyze the data, how we clean it up, how we transform it. So these are the different things we have covered so far. Then today we are going to focus on Delta Lake. So we'll talk about how do we reliably store the data in Data Lake using Delta format. Okay, so that's going to be our the biggest topic for today. Then we'll also look into what exactly is Databricks Unity Catalog. So like you saw in the diagram yesterday, Databricks Unity Catalog is it's a layer which can help us with security, governance, and cataloging. So that's what we'll talk about. We'll get a bit deeper into it and understand what we have there. And finally, we'll also look into how we can build production-ready pipelines using Databricks workflows. Now, when we talk about building production-ready pipelines, there can be orchestration pipelines, there can be ingestion pipelines, or there can be ETL pipelines. So today we are going to focus on two parts, building ETL pipelines using a new framework, and also we'll talk about the orchestration pipelines. All right, so that's the agenda we have, for today. So moving on, so we have already seen that what we have in the agenda. So today we are going to focus on Delta Lake. How do we store the data in Data Lake using Delta format? What are the different features of Delta Lake? How does it provide asset guarantees on top of Data Lake? Then we'll talk about Unity Catalog, as well as we'll look into building workflows with Databricks. All right, so that's what we have in the agenda. So let's move ahead, or let's continue from yesterday. I'm sure everybody has already signed up for Databricks free edition. So using that, we'll be able to complete all the activities, that we'll be discussing, today. Okay, so yesterday's activities and today's activities can all be completed through Databricks free edition. So I believe, you don't need to spend anything. You can just spin up the free Databricks edition, and then you can start working with it. All right, so with that, let's go back to our notebook where we have started building our ETL pipeline. And what we'll be focusing on now is how do we go and store the data in Data Lake. Okay, so that's something we're going to talk about. So let me take you straight away back to the notebook, and we're going to start from the same point we left yesterday. And I can see, yes, more people are there. So once again, welcome. And what we are going to focus on is how do we how do we store the data in Data Lake? Okay. So what we have seen, let me quickly walk you through, the things we have seen yesterday. Number one, we saw that how we're just going to define, let's say, a source folder path. We have basically we have stored our data in volume, so we are going to pick up the files from volume. Then we have seen, then we started basically reading those files as a data frame. Okay, so this is where we looked at the option of reading the file by using spark.read.csv. We can also go and, let's say, set up the header. Set up the header as true, which means the first record will be picked up, or the first record will be considered as the header. Then we also have the option of infer schema. This means, we would like to scan the whole file and infer the schema from there. Okay, so this is one of the options in which we can get the schema out of a textual file like CSV. Then we have another option. What we can do, we can also go and basically define our schema manually and apply it as well. So what you see is that we can just go and create a schema, define the column names, when we are going to read the file. So these are going to be the column names, these are going to be their data types. So we can manually define this, put it into a variable, and then once we are reading a file, we can say spark.read.csv, set up the header as true, which means now we don't require the first row because it contains column names. And let's go and manually supply the schema. This way, it will make sure that whenever we are reading the file, it's always in the right format. Okay, so this is how we can go and create a data frame. And of course, we can start displaying the data. Yesterday, we also saw the option of data profile. So basically, if we want to analyze the data, there are two options. Number one, we have the option of using describe function. So this basically shows us, the statistics, some of the statistics like the sum, count, min, max, and all these things. Basically, it shows us. And data profile gives us even more information. All right, so that's what we saw yesterday. Then we also looked into the different options to clean the data. For example, we can take a data frame, apply the filter conditions, right? So we can apply, multiple filter conditions in different formats as well. Like you can apply in a SQL-like format, or we can also go and, just take a column and then apply the condition. So totally up to you how you want to write the syntax. It doesn't make a difference in terms of, performance or managing that. Then we have seen some other functions like na.drop, so it helps us drop the null records. Na.fill, which helps us fill up the missing values. So I'm just quickly walking you through the kind of things we can perform using Spark. We can also go ahead and drop the duplicates. All right, so these are the different types of cleanup functions that we have seen yesterday. Now, what we, then after that, what we looked at, how we can start applying transformations. So, once we have the data cleaned up, now it's time for us to basically, add more columns, or let's say remove the columns not required, rename the columns, and so on. So what you see is that we can go and use these kind of methods like select. This will help us to basically, kind of select the columns which are required. And we can also add an alias saying that this is what the new name of column is going to be. Then we have seen that we can add additional columns or derived or calculated columns. So we can use the method with column, provide in the column name, and then we can define the expression. So that way we have we created yesterday multiple derived columns like trip time in minutes. Then we also looked at trip type column, so we can do an if else condition, and then based on that we can set the value of the new calculated column. Then we have seen how we can create trip year, trip month, trip day. So what you can notice is that just like we start doing it step by step activities of cleaning up or data, in the same way we transform the data as well. All right, so till this point, something we have seen yesterday, that our data frame is ready, and we have got additional columns and all in the data frame. Then, of course, we have the option of doing group by, aggregate, order by. We can do joins. We can apply ranking functions. We can apply partition functions. So lots of the similar types of functions that we have in SQL is something we can apply here as well. Okay. So now that our data frame is ready, now let's see, a new topic here. And what is that? Basically, it's about working with Spark SQL. Now, what is this working with Spark SQL? Now, if you remember yesterday, I mentioned that once you create a variable, or let's say once you create a data frame in, let's say in Python or Scala, you cannot go and share it with SQL, which means you cannot access that data frame in SQL because data frame is built in Python, and we would, and it cannot be accessed in SQL. This is where we have got one option available. If you still want to do it, there is one option available, and that's what we are going to look at. Now notice here that we have got a data frame created in Python, right? So this is the one which is created in Python. Now, I would like to build a report, and I know SQL better. I'm more comfortable there. So if I have to write the code in Python, sometimes I may not be very comfortable with that. Let's say if I have to write a big query, or if I have a complex query to create a report, that's something very, it's difficult for me to do in Python. That is where we can start using these Python or Scala data frames in SQL. How do we do that? So let's say we have this data frame in Python. Now I want to use it in SQL. So what we can do here, we can say use a method create or replace temporary view. Okay, so create or replace temp view. What this function is going to do, this function is going to create a view in SQL. Notice here, this function is going to create a view in SQL, which will be referring to this Python data frame. Remember, Python data frame is a table structure. Okay, so what we can do now, we can create a view on top of this Python data frame in SQL so that we can access this data frame in SQL. How do we do that? So this green taxi df is a Python data frame. And by using this function, I'm saying this is going to be the name of the view in SQL. Okay, so this is a Python data frame, and we have got a SQL view, by this particular name. Okay, so the Python data frame is green taxi df, and SQL view name is going to be green taxi trip data. Okay, so by using this method, now we are exposing this Python data frame in SQL. So think of this, think of this view like a pointer to basically Python data frame. Okay, so this is like a pointer we are creating to the Python data frame. Let's see how much time does it take to create this particular view. So I'm just hitting it. I'm hitting run, and you can see within less than a second, this view is ready. So basically you can now imagine that even if we have, if we are about to get a lot of data in data frame, still, once we are creating a view, it's going to be very, very fast because this is like a pointer to the data frame. Okay. So now that we have this view ready in SQL, so what we can do here, we can say in Python, we can use a method spark.sql, and now we can pass a complete SQL query into this one. So look at how easy it is, that if you know SQL better, you can just go and say, all right, let me take the data frame, create a view on top of it, and now we can just use that view inside our SQL query. So this way, we can just go ahead and create, we can just go and create a, use a Python data frame, run SQL queries on top of it, and that way, we can basically run our SQL queries. We can generate reports, and we can analyze the data. Okay, sounds good, everyone. Uh, does that make sense? Understood the idea? So we can just go and now hit run. So this way we are going to now basically run a SQL query on top of a data frame. Okay, so you can see now this is the output that's coming out from the data frame. Okay, moving on. Now that we have seen that how we can run a SQL query, but notice here that this SQL query is coming in a string format. I really don't prefer that way, putting up a SQL query in a string, because my query could be very long. This is where in Databricks notebooks, we can also go and run, we can just say, all right, this cell, I want to make it as a SQL cell. So I can click on this, so Python is the default language for the notebook. I can select SQL, and that way this cell will become SQL. This means now we can directly write SQL query in this one. So you can see now it looks a much better formatted query. I can just hit run, and we're going to get the same result. So ultimately, when I'm running this query, it's using the view. View is a pointer to the data frame, and now the data that is coming out is coming through that Python data frame that we have created. Okay, makes sense, everyone? You get the point that how we can use Spark SQL. So we can take the data frame, create a view on top of it, which is like a pointer, and now we can start running direct SQL queries on that view. Obviously, it's a SQL view, so we can start writing queries here, and basically it's referring to the Python data frame that has been created. Okay, fine, everyone. Is everybody clear with this concept? Any doubts, any questions? Feel free to, just like yesterday, feel free to put that in the Q&A panel or in the chat window, and we can take it up from there. Okay, just a quick check again. You can give me a thumbs up if everybody is clear about the Spark SQL concept. So take a data frame, convert, create a view on top of that data frame, which is like a pointer, and then simply go and start running SQL queries on it. So this way, we are now now combining the power of Python and SQL together. Or even if you have got views created or data frame created in Scala, that's something that can also be utilized, within SQL. Okay, so that's how it works. All right, so let's move ahead, and I can see yes, some people said yes, they are all good. Yeah, I can see more people saying yes, they are all set with this. So let's move ahead and look at the next part here. Now, I'm not going to go through reading the JSON. I'll leave it up to you to try this out. It's very simple and straightforward. And somebody is saying this view would be temporary, isn't it? How do I persist it? Please remember, this is a temporary view in the session that's going to go away. In fact, it's so as soon as you close the notebook, you stop the cluster, it's going to go away. If you want to persist it, so what I would recommend you is something like this. So first you write the output to data lake, and then you can create a table on top of it. Okay, or basically you can write the output directly to a table. That way you're persisting the data, and then you can directly use it. If you want to persist the view definition, you can do it like this. So what you can do, you can create your tables, put the data in there, and then create view on top of it. This temporary view that you are seeing here, it's like a reference created to the Python data frame. Okay, so it's not like that you can just persist this view definition. You can't do that. So if you want to persist the view definition, first you write the output to data lake as a table, or first you write the data to a table and then create a view on top of it. Okay, that's the only option. All right, so now let's move ahead. uh, and let's see how do we write the data to data lake. Okay, now first what I'm going to do, I'm going to say, all right, let's define a path here. So this is going to be the path of the output, or this is the output location. Now let's see how do we export the data or write the output to data lake. This is very simple and straightforward. So just like when we were reading the data, we were saying spark.read.csv. Now if we want to write the output, you can see that we'll take the data frame green taxi df dot write. So very simple, data frame dot write, and then we can say dot csv. This way we'll take the output of the data frame and write it in csv format in data lake. Okay, so you can see here that we are taking the data frame using the write operation, writing it out as a csv, and then while writing, if we want to define certain options. For example, I want to put the header in the file. I want to put the date in this particular format. I want to override the existing file. So that's something we can perform here. Okay, so let me go and run this one. So this is going to whatever data, so based on the data frame or whatever output that data frame is going to generate, that's going to be written to data lake. Now how is this going to look like? Okay, so we have understood yesterday how Spark architecture works. Now remember, I'm putting the file path here. Let me go to this path and see what exactly is it's showing up. So what we'll do here, we'll get to catalog, because I have stored the output into volume. So let's go there. Let's open up the volume. Okay, so let me just go to data files. You can see we have a raw folder from where I was reading the files, and I have an output folder here. So let's go to output folder. You can see that it's not a single file which has been created. Why is that? Because if you remember from yesterday, that once we are writing the output, or once we are reading a file, it creates partitions. Partition creates tasks, and tasks run individually on different cores. As soon as any task is done, it writes the output back to data lake. So that is why when we are saying that, okay, let's write the output to data lake, it is not writing as a single file, it's actually writing to a folder. And now if we open up this particular file, or in fact this particular folder, you can see that there are 4 basically files which are available here. See that? There are 4 CSV files which have been written. So what does that mean? This means that there were 4 tasks which were running, and corresponding to the 4 tasks, 4 output files have been written. Okay, does that make sense? So if you remember the diagram from yesterday, what we discussed, that once Spark is writing the output, each task is going to write its own output file. So since we have got, here I have got 4 tasks, so 4 output files have been written. This is how the distributed data processing works. Okay, sounds good, everyone. This is how, we go and write the output here. I can see a couple of questions are there, but let me just first, complete this part. What you can see that we are writing the output as CSV. We can also go and write the output in Parquet format. So how do we do that? We can say dataframe.write.parquet. So instead of saying dataframe.write.csv, now we are saying dataframe.write.parquet. And now once we go and execute this one, so this is going to write multiple Parquet files in the same output location. Okay, so let's just wait for this to complete, and then we'll also check, what is the size of the file and so on. Now that it is complete, let's come back here. Now, the CSV file, if you notice, once we wrote the output in CSV format, each file is around 8 MB. Approximately, each file is around 8 MB. Now, if we go back to the output folder, you can see now there is another folder created, greentaxis.parquet. Let's open it up. Again, we have got 4 files, which means we had 4 tasks writing 4 output files. But if you notice that because it's in Parquet format and it is using a compression by default, you can see that Parquet data is highly compressed. So instead of 8 MB files, or approximate 8 MB files each, we now have got 2 MB files each. Okay, sounds good, everyone. Got the idea, how we basically write the output to data lake. And remember, it does not write output as a single file. It depends, if it's a single task, it will write single output file. But by default, obviously there can be more tasks. And if there are more tasks, they are going to write multiple output files. Okay, so this is the first way in which we can write the output directly to data lake. But what is the problem with this one? The problem is, once we have written the data, everything is good. But once we have written the data, if somebody wants to read this data, they again have to, read the file. They don't know what is the schema. So they will just go and, they'll start opening this file, or they will use Spark. Then only they'll get to know what exactly is present in, what is the schema of those files. But on the other hand, what we can do here, we can just go back. Now, instead of basically writing the output into data lake as files, now we can write the output as tables. Okay, so what you'll see here, I'm going to use basically a database here. Okay, so let me just say I'm going to use catalog. So we'll talk about this Unity catalog. Okay, now what I'm going to do, I'm going to go ahead and create a database. So I don't want to write output directly to data lake. I would actually like to go and write the output to a table. But remember, these are not like Oracle or SQL Server tables. These are basically going to be Spark tables. Now, what is the difference here? Okay, let's see that. So I'm just going to write it here. Let's say you want to write output to data lake, right? So there are 2 options. Number 1, write, to data lake directly. So in this case, what happens is files are, in fact, we can say multiple files are written to data lake. That's what we have already seen. So multiple files are written out to data lake. And number 2, no metadata is registered with Databricks. And when I say no metadata is registered, what does that mean? This means that we are not storing, we are not storing anywhere what is the let's say, what are the names of the files, what are the columns we have in the files, what are their data types. So basically, we have no information of the metadata of these files, right? So let's say if I go back to the catalog, only the files have been dumped here. But what is the schema of these files? We have no clue of that. If somebody is coming to the folder, they want to read these files, first they want to read the data here, they first have to read the files, create a schema, maybe remove the header and so on. So they have to do all that stuff before they can start consuming it. That is where we can go and write the output directly. In fact, we can go and write the output as a table. So we can just go and write the output to data lake as a table. Now once we are writing it as a table, notice how the data is actually stored. Once again, when we are writing it to a table, it's going to be multiple files that are going to return to data lake. So when you're working with Spark, whether you are storing the data directly to data lake or you're going ahead and storing it as a table, in both cases, data is going to go, or files are going to be created, and they are going to be written to data lake. But then what is the difference here? When you're writing it as a table, metadata is registered with Databricks. Now this means, what is the table name? What are the columns? Basically, what are the columns available in the underlying files? What are the data types of those columns? What is the size of the data? So basically, we are going to have some metadata registered with Databricks. This is the benefit of writing, the output directly to data. Writing it as a table, because if someone wants to read the data, they can simply go and say, I want to use select star from table. So this way they'll be able, they don't have to read the data, apply the schema, nothing. They can simply go select star from table. By that, they will be able to directly read the schema here. So remember that in both cases, output is going to be written to data lake in file format, and then the metadata. But in case of table, the metadata will be registered with Databricks. Okay, so let me show you how do we write the output as a table. So first, let's go and create this database if not exist. And I'll show you where is this database. Let's go back to catalog. So of course you can click on this one. So let's go to catalog. Now in catalog, let me come to O'Reilly catalog and refresh it. And you can see there is a database which has been created. Now these are my old tables. So you can see that a database is now available, which is called TaxiDB. All right, so under the catalog, we now have this database. It's also called schema. So now, you'll see once Unity catalog has come in. So either you can call it as a database or you can call it as a schema, one and the same thing. Okay, so now the terminology has changed. All right, so what you can do, you can create a catalog. Under the catalog, you can create a database or a schema. And under the schema, you can start putting up your tables. Okay, so we have already created the database. Let's go and write the output directly to, directly as a table. So what you are seeing, the code is exactly the same, data frame dot write, mode as overwrite, but instead of saying .csv, we are saying .save as table. By only saying .save as table and providing the name of the table, the underlying files are going to get into data lake and the metadata will be registered with Databricks. Okay, so that's the benefit of using, writing the output as a table. Fine, everyone, everybody clear with this concept, and you can see how easy it is now that we have the the table created. I can just say select star from table. I can apply the where condition, limit clause, group by, joins, all kind of conditions I can apply, and I can have a look at the data. Okay, so let me know if anybody has any doubts, but meanwhile let me just quickly address a couple. I think 2 or 3 questions are there. Let's go and check it out. So one of the question is, will we be covering creation of table? Yeah, that's already, we have just done that. So question came in a bit prior to that. Another question is, what is the internal storage representation of the data frame? Is there a table? Is there a database engine working, or the SQL query is getting rewritten into Spark's internal code? Okay, so the question is about, when we talk about a data frame as a table, what is the internal representation of it? Now, please remember that this data frame, does not store the data with some kind of engine or something. We need to learn about some topics like RDD, which is the native data structure of Spark, which is called resilient distributed data sets. Data frames are basically built on top of it. Now, how does that internally happens? Basically, it does not store any data. Data frame actually does not store any data. Data frame basically is a set of steps you need to apply to prepare the data. Okay, and it's quite complex. Before we reach to this point, we have to learn about a lot of Spark internal concepts. But to keep it short, it does not have, when we create a data frame, it is not storing any data. It is basically a set of steps to be applied to prepare the data. Okay, you can think of it like this way. So this means that if I'm running a data frame, first it will read the file, then it will do some cleanup operations, then it will do the transformation operations, whatever we have defined, and then we can see the final output. Okay, so it's very because it's a very different architecture. It's not like when we are creating a data frame, it's storing the data somewhere. No, it's just a list of steps to be run before the output can be produced. All right, and then we have another question saying, can we combine CSV files into one? Any command available? Yes. Now, the question is about If we are seeing multiple Parquet files, can we combine it into one? The answer is yes. If there are multiple CSV files, can we combine it into one? Answer is yes. Or while writing the output, I just want one single file as output. Now, can we do it? Answer is yes, we can do that, but it is not recommended. Why is it not recommended? Because remember that if you why we are writing four output files. First of all, we are writing four output files because there are four parallel tasks which are running to write the output. Now, one task is writing one file as output. Okay, so that is why four tasks are there, four output files are there. But if you want the output as one single file, so what do you need? You need one task for it. One task means all your data comes in a single partition, and that basically kills your distributed data processing. So if you want to, if you want to write all the output as a single file, there are methods like coalesce method. So coalesce method will help you combine the output of different partitions into a single partition, but it is not recommended to use frequently or not on a big data set because it's going to kill your distributed data processing performance. Okay, so there is a method called coalesce, COALESCE. So this method, will help you basically reduce the number of partitions. And but if you reduce the number of partitions, obviously task will reduce and more data needs to be processed by a core. Okay, so you can, you have the option to use that. And somebody is saying database is same as schema. Yes, with the new terminology, either you say create database command, something like this, create database, or you can even say create schema. If not exist, it's exactly the same thing. Okay, so because the things have changed a bit. And final question we have is for making schema, for example, a Parquet on S3 for making schema available in catalog, should we always choose write it as table? No. So if you want to, first, let's say if you want to write it as a table, you must have the catalog and schema created. For example, if I change the schema here and say taxi db1 dot green taxi is managed, this is going to fail because this schema does not exist. So first you need to create the catalog. Under the catalog, you need to create the schema, and then you can go and write the table under that schema. So let's say if we come over to catalog here. So remember in the hands-on yesterday, you first went ahead, created the catalog. And once we create the catalog, for example, if we create O'Reilly catalog, under that, we go and create the schema. Okay, so you can see different schemas like TaxiDB. So this was we created as a database. This is basically a schema. So, we go and create this particular schema. We have a second schema here. And then under the schema, we can create the files. Or in fact, we can create the tables. So please remember that, without having a catalog and a schema, you cannot go and create a table. And it's not going to create the catalog and schema automatically. First, you have to define the catalog and schema. Then you can go ahead and write the output as a table. All right, so these are the two options to write the output to data lake. We can store the output directly there, but then there will be no metadata available, but then we can write it as a table. This will register the metadata with Databricks. And because of this, because the metadata has been registered, now we can go and write typical SQL queries directly on the table. So once we are running the queries on this, it's going to go to the data lake, pick up the files, and then show us the output. Okay, so for us, for business user, this might be a simple table, but in the background, it works very differently. It's picking up the data from data lake and then showing us the output. All right, so that's how we can, start building our ETL pipelines, extract the data from some source, analyze, clean, transform the data, run SQL queries if we want to, and finally go and write the output to data lake directly or as a table. You can choose any of these options. Okay, fine, guys. Everybody clear with this concept? Understood the idea about how do we build these ETL pipelines? You can give me a quick thumbs up if you're clear with this idea, or if you have any questions, you can let me know as well. Okay, all good. Understood all this concept of creating, storing the output directly to data lake or as a table. All right. Okay, so yeah, thank you. I can see, yes, a lot of people are saying they are clear. So let's move ahead. And, so you already have the notebook, which contains, the writing the output to data lake, working with Spark SQL, writing it as a table. So I would recommend you to, complete that notebook, which I shared yesterday, and do all these steps. Okay, so now let's move on to the next topic, which is basically introduction to Delta Lake. Now, this is a very, kind of a, I would say, a bit difficult topic to understand. So we are going to spend a bit of time, talking about what exactly is Delta Lake and how does that work. All right, so let's go and see, what exactly is Delta Lake and what is its purpose. But before that, it's important for us to know that what are the challenges we have, while working with Data Lake. Okay, let's go and see that. Now, once we are, let's say, I've just shown you that we can write the output, either directly to Data Lake, or we can write the output as a table. In both cases, basically the underlying files are getting created, or basically files are getting stored, in Data Lake. But let's see what are the challenges with that. Okay, now first challenge, let's say, what could happen if there is a failure in writing. Let's understand this scenario. Now, what you'll notice here, you know this says we have got a Data Lake folder, and in the Data Lake folder, let's assume we have run one job, and we have written the output here in Data Lake. That is why we have got one file, file1.parquet. With this scenario, how many tasks do you think must have been created in this kind of scenario? When you see this scenario and we have run one job, how many tasks do you think might have been created? Excuse me. All right, so we ran one job. We can see one file here. So how many tasks do you think might have been created here? You can put your answers in the chat window. Okay, I can see yes. Somebody is saying one, someone is saying multiple. Okay, and I could see some answers in Q&A as well. So basically, what is the right answer? Right answer is one. Why? Because let's say we are running a job. Job is going to create, let's say, some tasks. How many tasks? So let's say it create one task. So if it's creating one task, it's going to write one output file. And if we are going ahead and saying, let's say, if it would have been multiple tasks, we would have seen multiple output files being written here. Okay, so that is why, let's assume we ran the job. I'm sure there is only one task, because of which we have one output file. Now let's take the scenario further. Let's say you are now running the job again. Okay, and once you're running the job, you are going to write two output files. So when we are writing two output files, what does that mean? This means we have got two tasks. Task one is going to write this file, and task number two is going to write the second file. Okay, so we have two tasks which are running in parallel, and they are going to write two output files. Now, before we started running this one, let's assume a business user is coming, and business user wants to access the folder. So business user will try to access it, and user will see that there are a total of two records available on day number one. So on day one, we have written this file, and we have got two records here. Okay, so when user will read this folder, the user will see there are total two records which are available. Now let's say on day number two, we go and we want to write some more data to Data Lake. Okay, so what we'll do, we'll start a job, or we'll submit the code. It will start a job. Let's assume that it's going to have two tasks. Now two tasks mean two output files will be written to Data Lake folder. Okay, so how is this? Now let's say while this process is running, task number one is going to finish up faster, and task number two is going to take some time. Now, which means that, okay, task number one has completed. This file has been written to Data Lake. Now, let's assume what happens is, there could be a failure in the job. So remember that two tasks are running in parallel. One task has finished, and the file has landed into Data Lake. Now, at this point, let's assume the job failed. Now, why would job fail? It could be a bug in the code. It could be, let's say, it could be some issue in the data, or it could be, for example, a network issue, right? So there could be a network issue. The cluster has crashed, or maybe, driver process has crashed. Somehow, our machines are not working. So what happened was, because our cluster crashed or there was a bug in the code, our job failed. Because the job failed, now we are seeing this one file in the folder, but we are not seeing this file, the second file in the folder. Do you think, now if, or think about it, if a user comes and wants to read the data, how many records the user will see? 2 records from here and 1 record from here. So user is going to see a total of 3 records. Do you think this is the right data? Yes or no? And if yes, why? If no, why? Do you think that this data that we have in the folder that user is looking at, is this the right data for day number 2? Is this information right? Now, whatever data we have in the table with 3 records, is this the right information we have in the folder? Or what business is looking at, is this the right set of information? Okay, somebody is saying in Q&A, no, it's not. Okay, anybody else? Okay, notice here we have got, the first day we had 2 records, the next day we are just getting once, we are only showing 1 record to the business user. you know why? Because somebody has said missing information. Yes, this is the missing information. Why it's a missing information? Because it was supposed to be 2 more records from this one, so total should have been 5 records. Now why it is wrong? Let's say this is sales data. Okay, so on day number 1, business user is seeing that there are two, let's say the 2 products which have been sold, or we got 2 orders. Next day, when this process happened, now user is seeing that we now have basically 3 sales order. So ideally it is 5 sales orders which should have shown to which should we should have shown to the user, but now we are showing only 3 records to the business user. So because of this, they might think, okay, day number 1, we had 2 records. Day number 2, we have only 1 record, so our graph is going down. But actually graph is not going down. There are total 5 sales orders. So day number 1 they were 2, and day number 3 or day number 2 they were 3 records. So 2 on day 1, 3 records on day number 2. So this means our sales is increasing, but by looking at this tape folder, it looks like our sales have decreased. Okay, so what is the problem here when we are writing the data? Number 1 is this file is written. This file could not be written. So first, user is looking at inconsistent data. So this is not the right data. Okay, so this is the inconsistent data. Second problem, because we have written one file and we have not written the other one, now our folder is corrupted. So folder is now corrupt, because we have stored partial data into the folder. Okay, let me take a pause here and see if everybody is clear with this concept. Do you get the idea? So because we have not stored complete data, we have stored partial data here. So user is seeing wrong data, plus our folder has been corrupted because there is we have written one file instead of 2 files. Okay, so this way we have written partial data into the folder, and now our folder has been corrupted. Okay, understood this concept, what has happened here? So when we are, it may happen that once a job fails while writing the data, it may write partial output, because of which, we are going to see incomplete data or inconsistent data. Okay, so this is the first problem that we can face here. Now I think there is one question saying about reading the file. Since there can be many files in the folder, how do we read them all without explicitly giving the file names? So basically, if you now question is about, if we have to read this folder, how do we, how should we do that? Now in this case, let's say when we read the folder, what it does is it picks up all the files, combine the data, and then gives it to the user. So whether you are using Spark to read the folder, whether you are using Power BI, Power BI tool to read it, whether you are using Tableau. So these days, most of the tools support reading the complete folder. So when you specify the folder, it picks up all the files from the folder, combine the output, and then show it to the user. Okay. Another question is in the example on the sale, where we users Mohit, Ivan, Sabrina, assume Ivan is deleted. How do we remove it from the old Parquet file? Okay, we'll come to the deletion purpose or delete part a bit later. But I hope everybody is clear with this concept that if we are writing the output and if there is a failure in the job, our folder may get corrupted. Okay, let's look at one more problem here. Let's say this time, we are going ahead and let's say we have the same scenario. Okay, we have the data lake folder, one file has been written, and then, we have 2 records here, right? So we have got 2 records which have been written as part of one job. Now let's say that let's assume another user comes, and or let's say you start your ETL job and you're going to write, let's say, two files again. So there are two tasks. It's going to write two output files. Now let's say, we have started the job. One of the tasks has finished writing, and we have seen that file is being written. This is something we have seen, in the previous diagram as well. So you can see one file has been written. Let's say this file took 1 minute to complete, or this task took 1 minute to complete and write the output file, but the other task is going to take 1 minute and 10 seconds. Okay, so other task is going to take 1 minute and 10 seconds. This means this file will come in the folder after 10 seconds. So the first file came after 1 minute. The second file is going to come after 1 minute, 10 seconds. So basically the new file, second file will be written after 10 seconds. Our job is still running, but after 10 seconds, we are going to expect a new file here. But let's say during this time, once we have written one file and the other file is not yet written, during this time, if a user comes and wants to read the folder, again the user will go read the folder and see there are total two files with total three records present in the folder. Again, this is going to provide the user with inconsistent data. So user is seeing only two files as out, in the folder, while either it should be one file, which is this one, or it should be total three files. But what we see is we are seeing or user is seeing that only two files, which is file 1 and file 2. User is not seeing this file because it is not yet written. So what you see is that while the ETL process is going on and you're writing the output to your folders, if somebody goes and starts reading the data, they are going to see inconsistent data. Okay, do you get the scenario that what will happen in case of parallel reads and writes? You're running your Spark job, it is writing the output files, but meanwhile, if somebody comes and reads the folder, because the job is still running, all the files are not yet written, and because of this, the user is going to see inconsistent data. So, in case the job fails, our folder can get corrupted and user will see inconsistent data. But even if the jobs are running perfectly, you know, then let's assume you're writing the data on one side and somebody is reading the data on the other side, that's going to cause inconsistency issues. Okay, so this is the other challenge we face with data lake, that if somebody is writing in the same folder, other is reading from the same folder, then they can see inconsistent data. Okay, so these are some of the challenges that we face with data lake, that data lake does not provide asset guarantees. Okay, so what you'll notice is that it does not provide atomicity, that once we are writing the data, it's not an atomic transaction. So half of the data is written, half of the data is not written. So basically it's not providing atomicity to us. Then there is no consistency of data. We have just seen the diagrams that if a user comes and wants to read the data, the user is going to see inconsistent data. So data lake basically does not provide asset guarantees. So what are the other challenges with it? Data reliability. So if somebody is trusting that folder that it will contain the right information, but what if our jobs have failed and table has corrupted or our folder has corrupted? There is no option for us to roll back. How will we go and roll back? Either we'll take some backup, and then restore it, or maybe we'll have to manually go and find each and every file which has been written in the current transaction or in the current process, then we have to delete it. It's not very easy, and you're not going to do these things in production. Okay, so that is why the data reliability is a very big challenge, or I would say it's a big challenge with data lake. Then we have got, there is data reading may be inconsistent. We have already talked about it. And there is no data validation when you're writing the data. Let's go back to the previous diagram. So let's say, on day number 1, we have written this particular file. Let's assume this when we have written the file, this basically is a string column, or let's say this is an integer column. Next day when I'm writing a file, maybe I might have some bug in the code, because of which this could become like a string column. So maybe by mistake I've inserted like a record A in ID column, so this became a string column. So there is no data validation happening when we are writing the data to data lake folder. Okay, so you can see there are several challenges here while working with data lake. Consistency is a problem. Can be data corruption, so there are no rollback options. The data reading could be inconsistent, or there is no validation when we are writing the output. So you can see these are some of the challenges. There are more. You cannot perform updates on these files. You cannot perform delete. So let's say if you have a CSV file, as an output, you cannot perform updates, deletes, merge on these files. Okay, there are no constraint options. So just like databases, I can't say that this column is not null. So I cannot go and apply not null constraints or check constraints on the files. Then performance also is not as good as what you see in databases when you are let's say running a query saying select star from table where id is 1. Okay, because remember, it's not a table, it's a set of files present in data lake. Okay, so these are the challenges that we face when we are working with data lake. Now let's see if everybody is clear with this concept of what kind of challenges could be there. So I've just tried to show you some scenarios which actually creates problem for data lake. Okay, let before I go forward, let me do a quick check. Guys, everybody clear? Any questions or any doubts? You can give me a thumbs up if you're okay, or if you have questions, you can put that in the chat window or in the Q&A, and we can take it up from there. All right, all set? Everyone, any questions? Or you can also give me a thumbs up if you're fine, understood this concept, like what are the challenges we can face with data lake. Consistency challenges, the simultaneous read and write challenges, corruption issues, inconsistency data, no updates, merge, delete, no constraints can be applied, and query performance is also not that great. When we have a very specific query like where ID is 1. Okay, so these are the challenges we face here. How do we solve this? This is where we have got Delta Lake. Okay, so this is the architecture we saw yesterday, that we can this is the Databricks architecture, and one of the key components we have in Databricks is Delta Lake. Okay, so remember that Delta Lake is an open source project which helps to bring reliability to Data Lake. Now, what are the other options available? So Delta Lake is one of the projects. We also have Apache Iceberg, and we have Apache Hoodie. Okay, so there are basically two more competitors to Delta Lake: Apache Iceberg and Apache Hoodie. Some of the platforms are supporting Iceberg, some of the platforms are supporting Delta Lake. For example, Databricks support Delta Lake. Uh, Microsoft Fabric, Synapse, they support Delta Lake. Then on the other side, we have Snowflake, which supports Iceberg. AWS, which supports Iceberg. So what you see is that different vendors are supporting different formats, but they all do the same thing. They try to bring consistency or asset guarantees on top of data lake. Okay, so that's what these different tools are trying to do, trying to bring Databricks database like features on top of data lake. Okay, so let's go and focus on this part. What is Delta Lake and how does that work? All right, now first of all, let's take an example and see how things work internally. For example, let's say we have Data Lake here, and what we would like to do, I'm running, we are again starting to run a job, and once we are running a job, we are going to write one file as output. So this means there is one task only, so this is going to write one file as output. Now, once we are writing this data, or once the job is writing this data, first of all, it's going to write the file. It's going to write the output file here. Now, after it writes a file, it does some extra work. What is it? What is the extra work? Along with saving this particular file, it basically creates a subfolder, under in the same, let's say under the same folder, it's going to create a subfolder, which means, let's say if we are storing customer data, so there will be a customer folder, and then this file goes into the customer folder, but under customer folder there is a subfolder which it is going to create. So because we are going to, okay, so this is the subfolder that will be created. All right, so let's say when we are writing the output as a CSV, it will only go and dump the files into data lake. But when we are going ahead and writing the output in using Delta Lake, it's going to write the output files again in Parquet format. Okay, please remember, when we are writing the output in Delta format, it's going to write it in physically, it's going to be in Parquet, plus it's going to create a subfolder called _delta_log. And then in this folder, it's going to write a file 0.json, which basically represents a transaction. So what you see is this is all Delta log is also known as transaction log. Okay, so Delta log is nothing, but it's a transaction log which stores the information of each and every transaction which has happened on the folder. Once again, this underscore delta underscore log folder is basically, it's also called as transaction log folder. This means whatever transactions you will do on the table, so whether you are inserting the data, whether you are deleting the data, whether you are, let's say, updating the data, so whatever operations you are doing, the information will be logged in this transaction log folder. Okay, so how is it logging the information? Now, this file might have, let's say, 1 million records. Okay, because it contains data. So it might have 1 million records, but then when you look at the transaction log entry, it will be called, let's say, 0.json, which is the first transaction. Okay, so first transaction is 0.json. And in this particular file, it is only going to say add file1.parquet. This means file1 is now part of our data. Okay, so just notice once again. So let's start from here. So let's say you're running a job, you want to write the output. So first it's going to write the output file in data lake folder. When all the tasks are done, remember, when all the tasks are done and all the output files are written, then it's going to put a file, in transaction log folder called 0.json, and it will say add file1.parquet, which means file1.parquet is now part of transaction. Okay, so this is how Delta Lake works. It not just write the output files, it also goes and make an entry into a subfolder called the Delta Log folder. It's going to make an entry there, marking the information that file1.parquet is now part of transaction. Okay, so this is how we start writing data to Data Lake. Let me give you a couple of more examples. Let's say now we are running a second job, and in this second job we have got two tasks. Okay, so we have got two tasks here. So two tasks means two output files are going to be written to Data Lake. Now, how will this work? Remember that it's going to write all these output files into Data Lake folder when all the files are written. So there were two tasks. So when both the tasks are complete in this case, then only an entry will go into transaction log saying file 2 and file 3 are now part of transaction. So what this will do, this will add another file. The file name is going to be 1.json. You see that? So this is the first transaction. This is the second transaction. So now it's writing another file here, 1.json, and saying add file 2. This means file 2 is now part of transaction. Add file 3, which means file 3 is part of transaction. Okay, so when we are writing the data, now carefully notice, when we are writing the data in Delta format, first it will write all the partition files. Okay, step 1, it's going to write all the partition files, and step 2, once all the files are written, then it's going to make an entry into transaction log. Okay, questions, anyone? Everybody getting the point? How do we start working with Delta Lake? So Delta Lake is an open source project. It's not just helps us write the data to Data Lake, but it also writes an entry into transaction log. Okay, so the question is, there is one question saying, does each job create a new log file? Yes, absolutely correct. So each job writes only one transaction log entry. So let's assume that, let's say you're running a job. Okay, so you start a job and you have lots of data to process. And let's assume this job is going to have 100 tasks. Okay, so let's say this job is going to have 100 tasks. So how many files are going to be written out? Because there are 100 tasks, so total 100 output files will be written here. But how many files will get into transaction log folder? Only one. So what will that be called? 2.json. And what will we store, or what is it that we're going to store in 2.json? Add file number 3, add file number 4, add file number 5, add file number 6, and so on. So basically, this particular 2.json will only contain information of 100 files which have, basically it's going to have the file path, and it will say add. So this would mean add and file path. This means this file is now part of transaction. So every job, whatever job you will run, it's going to write one single file as, one transaction file as output. Or in fact, not output, it's going to write one transaction file after all the partition files have completely been written. Okay, and somebody is saying 0.json is equal to transaction log. No, 0.json is the first transaction log. In fact, we should say this is basically the first version that we are creating, or this is the first transaction that has happened. So 0.json represents first transaction, 1.json represents second transaction, and so on. Okay, and somebody is saying, what if the task fails? Now, very interesting. And somebody, and the person is saying that I'm sure you will be covering it soon. So let's talk about it. What is going to happen if the job fails here? So please remember, okay, let's see if I have, yeah, same thing, let's go and look at the content. So what is going to happen if there is a failure while writing the data? Okay, so and before I cover it, before I talk about it, another question is the source file always Parquet format? Now please remember that when you're writing the data in delta format, and somebody is saying underscore delta underscore log is transaction log, yes, this is transaction log. Okay, so this is basically folder name is this one, but this is called transaction log. Okay, now once you're writing the output in delta format, the data will be physically stored in Parquet files. Please remember that once you're writing the data in delta format, so just like we write it in CSV format, Parquet format, JSON format. So when you're writing the output in delta format, it's actually going to it's physically going to write the file in Parquet, but along with this, it's going to make an entry. So plus sign, it's going to make an entry into transaction log. Okay, so I hope everybody is clear. So when you're writing the, can you use any other format? No, it will always be delta. If you're writing the output in delta format, it'll basically be in, physically the data will be stored in Parquet format. Okay, so Parquet files are written, then an entry goes into transaction log. Now, one thing to remember before I show you, how what will happen if failure occurs. Please remember during writing. Okay, so during write operation, first all the partition files will be written, then an entry goes into transaction log. Okay, so this means for this particular job, this is, first this is written, this is step number 1, this is also written, so this is part of step 1. So when all the files are written, then only an entry goes into transaction log. Okay, so this is how we work with Delta Lake, that first we write the, we basically write the partition for all the partition files, and then an entry goes into transaction log. Now what about the read operation? Read operation is reverse of it, reverse of that. So let's say if you want to read the files, what will happen? In case when you want to read a particular folder, first it will go to the delta log folder and start reading all the files from top. So what will happen in this case? So when it is first reading all the transaction log files, it will say, okay, let me collect a list of files we are going to read. Look at that once again. So if when we want to read the particular folder, okay, so let's say we want to perform a read operation of the folder, first the request will go to the delta log folder, and it will start collecting a list of files it's going to read. So once it will read the first file, it will say add file 1. Okay, so which means we are going to read file number 1. Then it will come to the next one. It says add file 2. Okay, we would like to read file 2. Then add file 3. So we are going to read file number 3. So first it goes through the transaction log, captures the list of all the files it is supposed to read, and then once it has gone through the transaction log, now it has a list of files it's going to read. So it's going to read file 1, file 2, and file 3. Okay, so I hope you get the idea that what is happening in case of write operation. So please let me also write it down so it makes it very, very clear. So when you're writing data, let me write some points here, which you can, take a note as well. So writing in delta format. So when we are writing in delta format, the partition files are written in Parquet format. Okay, and then an entry goes into transaction log, or basically delta log folder, an entry goes into transaction log. When we are reading data from, in fact, the first thing, partition files are written in Parquet format. All files are written before going to next step. Okay, so first all the partition files are written, then an entry goes into transaction log. Number 2, when you want to read data which is in delta format, so what will happen when you want to read data which is in delta format? Number 1, It's going to read all transaction log entries, prepare a list of files to read, and then only read Parquet files. Okay, do you see that? So read all the transaction log entries first, then you go ahead and prepare a list of files to read, and then only read the Parquet files. So this is how the reading and writing works in Delta Lake. Okay, now before I go forward and answer that question, what will happen on failure, let me quickly address some questions here. So the first question is the source file always Parquet? Yeah, we have already discussed. So the source file will always be in Parquet format. Another question is a delta log will always contain two JSON. First JSON will contain first file and second one will contain the rest. No, for every file that we are or for every transaction that we'll do or for every job that we'll run, one file will be added to the transaction log folder. Okay, so if you look at this diagram, so this is job number one. So this information goes in. This is job number two. Information goes in. Let's say there is another job and you are supposed to write one. Let's say there is a job number three, and job number three has got one task. So what will happen? One file will come here. This is going to be file number 4.parquet, and an entry will come here in the transaction log. What will be the name for this file? Let me hold here. So we have job number three writing one. There is one task. So one task is going to write one output file. So this is going to be file 4.parquet. Okay, but what will be the name of this transaction log file? So we have file 4.parquet being written out in data lake. What will be the name of transaction log file? Okay, I can see one answer. Rest all, what do you think will be the name of this file? Yes, everybody is sharing the right answer. So it's going to be 2.json because it's going to be transaction number 3. So 0 is the first transaction, 1.json is the second transaction, 2.json is going to be the third transaction. Okay, so that's how it works. All right, one more question saying, borrowing the fail question, did you mean even if some files are successful? Okay, we'll come to the failure part. Another question, would it be possible for you to add this note file in GitHub? I'll share it here in the chat window, and you can just download the notes and keep it with you. I hope that will be okay. Okay. Another question is, does new transaction have reference to old? No. When you're writing this one, it does not have a reference to the old one. Okay. Now let's see that how we are going to deal when there is a failure in writing the data. Okay. Let's say this is the current scenario. So we have, let's assume we had job number one. Job number one had one task. Task number one, it has written this file, and once this file is written, it is writing it to a delta log folder that file1.parquet is part of transaction. Then number two, let's say this is the job. Let's see what will happen if this job fails. Let's take the previous scenario. Okay, let's say the job is running. This particular task is going to finish in 1 minute. The other task is going to finish in 1 minute 10 seconds. Right? So this is what we discussed previously also. Now what will happen? Let's assume that this file has been written. So that this task is complete, file has been written, and this file is not yet written. Now let's say what will happen if there is a job failure and we were not able to write this file. Remember that since we are not able to write this file, job is not complete, no entry goes into transaction log. Think about it again. So what is the writing process? Let me show you here. What is the writing process? That first all the partition files are written, and then an entry goes into transaction log. Since our job failed and not all the partition files were written, no entry goes into transaction log. Okay, do you see that? So once this file is written, but somehow our job has failed, so no entry for file2.parquet. So this is file2.parquet, no entry goes into transaction log. Now, why is this beneficial? Let's say there is a user who would like to read the data. Now, user wants to read this folder, which is in Delta format. So remember, what is the reading process? First, it will go to the Delta log folder. What is it? The next thing it's going to do? Collect a list of files it is going to read. So what is the list of files it will read? Read file1.parquet. Okay, so file 1 it's going to read. Is it going to read file2.parquet? No, because there is no reference to file2.parquet in delta log. Once again, if while you're reading the data, it goes to delta log folder, starts collecting the list of files which it is supposed to read. So it will say file 1, because this is what we are going to read, but there is no reference to file number 2. That is why it will not read. It will only have file 1 in the reading list, and correspondingly it will only read this data. So even if there is a job failure in writing the data, any file which is, let's say, any file which is written out, but it is, it's not part of a complete job, there will be no entry that will go into transaction log. And that is why delta lake, that is how the delta lake helps us to basically maintain consistency of data. Okay, do you get the idea how it maintains the consistency? So consistency is maintained because unless the file is referenced here, or unless the partition file or parquet file is referenced in the transaction log, it will not be considered as part of the data. Okay, is it clear now? Everybody got the point? What will happen if there is a job failure in writing the data? Any partial files which have been written, they will not be referenced in they will not be referenced in the delta log folder, because of which they are simply going to be ignored. They will not be considered as part of the data, even though physically this file still exists. Let's say this file has got 2 records. This file has got, obviously this file has 2 records, this file has 1 record, but when user is reading the folder, user is going to see only 2 records, because based on file1.parquet, only 2 records are there. There is no reference to this file in transaction log folder, so there will be 2 records that will be read, making sure we are getting the right information. Okay, and the next obvious question is that, which somebody has just asked, that is it going to perform, how are we going to do the cleanup of these files? So there is a very simple command available, using which we can remove all those files from the folder which are not referenced in transaction log. Let me repeat the sentence if somebody is taking a note. So please remember, there is a simple command available called vacuum command. What that command will do, that command will remove all those files from the folder, whose corresponding information is not available in delta log. So because file2.parquet information is not available in delta log, it's going to be removed once you run that cleanup operation. Okay, get the idea that though obviously this file is physically still present, which is kind of a dangling file, not required. So you can clean it up by running a weekly job. You can just clean up these files, okay, which are not referenced by the transaction log. All right, so with that, let me just quickly check if everybody is okay. Then we can just go and take a break. Guys, everybody cleared so far with this concept? Getting the points that how delta lake is first writing the output into ever transaction log, and then when reading the data, it will only consider the files which are referenced in transaction log. So like this file is not present in transaction log, it will not be considered as part of data. Okay, make sense? This is how the delta lake works. I'm going to show you more diagrams, more scenarios. Then we are going to practically also look at all these things. Whatever you're seeing in the diagram, we're going to practically go and look at in the demos as well. Okay, so I can see yes, a lot of people are okay. So thank you for for sharing, for raising your thumb. And let's go and take a quick break of 5 minutes. After the break, let's look at some more scenarios about parallel reads and writes, updation, deletion. We'll talk about all those things. Okay, so let's take a break of 5 minutes. I'm going to start the timer and I'm going to catch you in sharp 5 minutes. All right. So is everyone back? Uh, you can just let me know if you are here. Just give me a thumbs up, and I'll just quickly share my screen, and we'll continue our discussion from where we left off. Okay, I can see there's a big question there, but I'm not going to, I can look at it maybe during, let's say during hands-on, because it's quite a long one. So we'll take it up during hands-on, but let me first let's go through the content here. Okay, so I hope I hope everybody is getting the idea what Delta Lake can do for us, and there are many more things Delta Lake can do. That's what we're going to talk about in the next 1.5 hours. So what you see is that we have looked at one scenario: what could happen if there is a failure in writing the data, right? So we have already talked about it. Now let me show you one more scenario about parallel reads and writes in case of Delta. So let's look at that. Let's say we have got the same scenario here. We have got data lake, and we have one job has written one output file, and correspondingly there is one transaction log entry, which is there. Now let's take the same scenario that we are going to run the second job. This is going to write both the files, but remember we that one task might finish faster than the other one. So since we have got two tasks here, so this task might take 1 minute, the other one could take 1 minute and 10 seconds. So the second task is going to write the output after 10 seconds. So this means one file is written, but remember no entry has gone into transaction log. The entry will only get into transaction log when all the output files are written. Okay, when all the output parquet files are written, then only the entry will get into transaction log. Now, at this point, once again, a reader comes, wants to read the data. So remember that reader will first go to Delta log folder and read. What will reader see? Add file one, which means file one it is supposed to read. So it's not going to read file number two unless the file number three, all the files, which is file number three, has been written. Okay, so that means that since transaction log only has 0.json, it will only read file number one corresponding to it. This means we'll continue to see consistent data. So only when the job will finish. So what will happen if once the job finishes? So there will be one file here. Okay, 3 columns, 2 records. Okay, so we are going to have this file number three also here. Okay, so this file number three will be here. Then we know that entry will get into transaction log. So what will be the entry? Add file number two, add file number three. Okay, so only when the job is finished, this entry will come. And then if a user wants to read the data, then the user will see add file one, add file two, add file three. So it is going to read all the three files. So it is making sure that we never read partial data or basically dirty data. So those coming from database background. So I'm sure you know about the dirty data concept, that while the data is getting written, we don't want to read it. We only want to read it when the transaction is complete. And that's what Delta Lake is helping us do, making sure that we always read consistent data. Okay, now here is another interesting part that we are going to talk about. So this is two more slides. We'll spend around 5 to 7 minutes understanding this, and then we'll go and look at the demos, how we can work with Delta. Okay, meanwhile, I'll just quickly run the query just to make sure my cluster does not stop. Okay, so everything is okay. So let's come back here and let's see what will happen when we want to update the record. Now updating the record is not possible in CSV. Updating the record is not possible, or deleting the record is not possible in CSV or Parquet. So but updating, deleting, merging, this functionality is also available on Delta Lake. So just some things that we do in databases, insert, update, delete, merge. So these kind of things, or these kind of types of transactions we can perform on Delta Lake. Okay, let's see how. Now let's say I'm sure everybody knows this scenario. Let me hold on for a second. Can you tell me, by looking at this scenario, how many jobs have actually run? By looking at this scenario, can you tell me how many jobs have actually run? And please give me a reason for it. Okay, just want to see how many of you can get this right. How many jobs do you think have run for this particular scenario, and why? Okay, someone is saying one, one, why? And yeah, more people are saying one. And why is that? Yes, somebody is saying there is only one log file. Absolutely right. Because, we have run only one, let's say if there is only one log file, this means there has only been a single transaction on the table, or basically on the folder. Okay. Now let's look at a very interesting part. What I want to do, I want to run a typical update statement, update table, or update the file folder location, where, set amount equal to 30,000, where ID is 1. Okay, that's a typical update statement I would like to write here. Now let's see how the update statement works. First of all, we are saying update the amount to 30,000. Okay, where ID is 1, where is record with ID number 1. Okay, can you see? I'm sure everybody can see that record with ID number 1 is present in file 1.parquet. Right, guys? I'm sure everybody can see, can clearly see ID1 is present in file 1.parquet. Now we want to update this record and basically change the amount from 20,000 to 30,000. How actually, let's see how Delta Lake handles this kind of scenario. In this case, when we are doing an update, so, and remember the file, ID number 1 is present in file 1. So what will Delta Lake do? It will create a new file. See here, it will create a new file, file3.parquet. So you can see, it's creating a new file, and it's going to be a copy of file1.parquet. Okay, and why I'm saying copy? Because first it will copy all the unchanged records from file 1 to file 3. Do you see that ID number 2 has not changed? So we are going to make a new file, copy the records from file1.parquet which have not changed. So these are the unchanged records. Okay, so these are the unchanged records. But along with that, it will now copy the record which has modified, and you can store the modified record here. So ID number 1, name and the amount to 30,000. So that's something we are going to put that in the new file, file3.parquet. Okay, get the point. Let me show you once again. So if we are saying update the amount to 30,000 where ID is equal to 1. So first it will find out where is ID number 1. That's something we can see from here. ID1 is here. So this means that now we're going to create a copy of file1.parquet, which is file3.parquet. So we are kind of creating a copy of this one. And then all the unchanged records. So remember, let's assume there are 100 records in this file. So only one record we want to modify. 99 will exactly be the same. So 99 records will be copied as it is here. Okay, and one modified record. So this one modified record, it's going to basically be added in the new file. So modified record will be added, plus all the unchanged records will be copied as it is. Okay, now once we do this, so how many records are there? 5 records. But actually, do we have 5 records? No, we only have 3 records, with one being a modified record. Okay, so we have just, remember once again, we should only have 3 records, with one being a modified record, not 5 records. So what information will get into transaction log? Again, there is an entry in transaction log, but this time it will say remove file 1. Why remove file 1? Because we have already copied the data from file 1 to file number 3. Once again, it says, once it has made this particular entry, then it adds a second entry in, or in fact, then it adds an entry into transaction log saying remove file 1. Why remove file 1? Because the data from file 1 has been copied to file number 3. So remove file 1 because it is no longer required. We have already copied the data from it, and add file number 3. Get the idea? So remove file 1 because we have already copied the data from it, and add file 3, because that is where the new data is there. Okay, so once we write it, the transaction is complete. Now let's take the other, let's think about it, that what will happen if somebody comes and wants to read the folder. Okay, so what is the process of reading a folder? First, it will go to the Delta log folder and start preparing a list of files. So what are the list of files? Add file 1. Okay, so file 1 is part of reading list. Add file 2. So file 2 is part of reading list. Then we have remove file 1. So file 1 is no longer required. Don't read that file. So this means it's going to remove file 1 from reading list. Then once again, it says add file 3. So file 3 is going to be part of reading list. Okay, do you see how the update record is working here? So when it sees add operation, it will put it in the reading list. But if it sees a remove operation, it is going to remove it from the reading list. This way, it's showing that only file 2 and file 3 are part of reading list, and it will go corresponding, to this list. It will go to file number 2, file number 3, and read the data. Do you think by reading only these two files, are we getting the right records? By reading only file 2 and file 3, are we getting the proper records, or are we missing something? Think about it. Do you think that by only reading file 2 and file 3, are we getting the right set of records or not? Okay, so we prepared a reading list, where we looked at file 1, yes, part of reading list, file 2, not, yes, part of reading list, file 1, please remove it from the reading list. So we have removed that and add file 3. So file 3 is part of reading list. So what you see is finally it is showing us only 3 records, including the modified record. Okay, so it's including, it's giving us 3 records, including the modified record. And that is basically the right set of data. See, we are getting 3. Earlier we had, something like this, 3 records. Now we have added one more file. So now this is the right set of data with 3 records, including the modified record. So this is how, we basically update the data in Delta Lake. Okay, so I could see there are, few questions. Let me quickly address them before I show you, the last part here about deleting a record. Okay, it's very similar to how do we update the data. So one question is, will there be a way to refer back to the original file from new file created? Yes, you can see that. So when we say remove file 1, add file 3, so basically we get to know that from here, actually you don't need to open a file manually to see the data. There are commands which is called time traveling. We are going to see that. If you're coming from Snowflake or other, these kind of backgrounds, I'm sure you know time travel. But if you're not from Snowflake, basically time traveling is a feature which will help us look at even the older versions of the data. And I'm going to show you in the demo. Okay, so yes, you can go and look at the older version of the data. Another question is, so all records stay grouped together transactionally? Yes. So all records, will be grouped by, so you can see all the files are getting grouped by this particular transaction entry. And because of this grouping of files, you are able to, get the records which have been added, which have been modified, and so on. Okay. Another question is, I guess if Parquet files are managed, it is not bad, but if file1.parquet is not cleaned up, your storage will increase. Yes. So now, because file 1 is no longer required, so we need to physically remove this file because it's no longer required. Now, how do we do this? Again, by using something called as a vacuum command. So vacuum command will help us, clean up these files. So you can run this particular job or run this particular command on a weekend and clean it up. Now, here is a very interesting part. In fact, let me write down here to clean up any unused files, created in Delta folder. So you can use vacuum command. Okay, so there is a vacuum command available. You can use it to clean up the files. In fact, old files are used in time traveling, which means if you want to look at basically to look into older versions of data. So let's say you are modifying a record, but at some point later you want to find out, okay, what was the older value? So you can use time traveling to look at the older versions of data, and these unused files are helping you going, these unused files are going to help you do that. Okay, so it's very important that you basically do the vacuum after a certain period of time. Now, here is a good thing. Databricks has a new feature called predictive optimization. What is this predictive optimization? If enabled, Databricks will automatically clean, you know, unused files from Delta folder after a certain period of time. You can define how, when you want to remove it. So you can say 1 week, or you can say 1 month, or you can say 2 months. So if this feature is enabled, Databricks will automatically clean up the unused files in the background, and you don't have to manually run vacuum command or anything like that. Okay, got the point. So very interesting feature. So you have got a predictive optimization feature. I have seen many organizations enabling it. Obviously it will require some compute in the background to periodically run, but then you don't have to manually run it yourself. Databricks will automatically run this in the background and clean up all the unused files. Okay, so and then somebody saying F2 and F2 have complete records. Let's see that. So F2 and F3 have complete records. By removing F1, there is no time travel or versioning. Yes. So you have got these files, which is the latest version. So if you want to do time traveling, you need this file because this contains the older version of data. But if you remove this file, time traveling is not, time traveling cannot be done. Okay, and somebody is saying if the record is updated wrong, can it be rolled back? Yes, that's a good feature of having this, having it this way, that if there is if you modify the record by mistake, okay, what I can do, I can simply run one command saying restore, restore the folder. When I say restore folder to previous version, it will automatically, just take you back. Okay, so basically rollback is a very interesting feature that you can set up. All right, and all right, so this is how we update the data. Let's go and practically see how we can do it. Actually, update is very simple. Or in fact, delete is very simple. So what will happen if this is the scenario, this scenario, and now you want to say delete where id is 1, id number 1 is in file number 1. So what it will do, it will again create a copy of this file by copying all the unchanged records and ignoring the record which is supposed to be deleted. So now a new file has been created, and what it will do in the transaction log, anyone, what do you think will be added in the transaction log here in 1.json? So when we say delete where id is 1, a new file has been added, all the unchanged rows has been copied, and the record supposed to be deleted has been ignored. Now what information will go into transaction log? Okay, I'll just hold on for a few seconds. Let's see how many of you can get this right. What information will get into transaction log? Perfect. People are, everybody is hopefully is getting the hang of it. So somebody is saying remove file 1, add file 3. Yes, that's absolutely right. So remove file 1 because that is no longer required, because we have already copied the unchanged records from there, and add file 3, which is the new file. So now if somebody wants to remove file 1, add file 3, not 2. Okay, so this is how it looks like. And when somebody wants to read the data, so as part of the reading list, we have file 1, file 2, no file 1, file 2, and file 3. So this contains 2 records. This is the right data, and where we have the the deleted record gone. Okay, so that's how we basically work with delta. All right, so it's time for us now to practically see these things. We'll spend around maybe 20-25 minutes looking into all these things practically, and then we'll we can do some hands-on as well. Or maybe let me see, we have some time. All right, so let me take you to one more notebook here, and this notebook is also there in the GitHub repository. You can once we'll get into hands-on, you can start working with it. But first let me show you a few things here, and then of course you can start with you can work on do the hands-on. Another question is, can we compact the transaction file? Yes, we have that option. I'll tell you during the hands-on. Another question is which command to use if we wish to only clean the failed jobs file but want to keep the unused files that are part of the remove for time travel. Vacuum only does that. Okay, so vacuum command will first remove all those files which are no longer referenced, or which are not referenced by any transaction log. Number two, you can also go and uh, you know if you want to store the historical versions, vacuum will help you do that. Okay, so vacuum has that capability. Another question is regarding uh, what if you have a pipeline that runs daily and update your database. Okay, so daily we are updating the database. Do you modify the data in the data lake, or what is the best way to set up the data pipeline? Yes, you can run a pipeline which is going to update the data on a daily basis, which means new files will be added, some file will be marked as removed, so that information will keep on going in the transaction log. But then, on a periodic basis, you can run vacuum or let predictive optimization of Databricks start cleaning up the older files automatically for you. Okay, so yes, so basically, the process remains the same. You can keep updating your records in the database on a daily basis. And the transaction log will maintain information of which records to delete, which records to add, or basically which files to add, which files to remove. And once all that information is there, uh, you can just run vacuum to clean up unused files whenever, on a periodic basis. Okay, so let me know if still that answers your question. I can take up in more detail during hands-on, but let's first go through this part. I can see a lot of interesting questions coming, but let's go through this, and then we'll talk more about it. Okay, so what I'm going to do, I'm going to start here by setting up the source folder path where we have our source files. Let me start using this O'Reilly catalog. Okay, guys, don't worry. I'll make sure I come to each and every question and try to address that. But let's first, try to go through, this piece of code. So let me just go and, set up the input folder and the output folder. I'm just setting up some variables here. Now let's go and read a source file. Okay, so this process. I'm going to define the schema. This is always my preference. Manually define the schema and then read the file. And once we have the schema defined, let's use the same command, spark.read.csv, and provide the schema and set the header as true. Okay, let's go and run this one. So we are going to create a data frame. Okay, now everybody knows this process. We're going to create a data frame. Once this data frame is created, let's go and write this in Parquet format and in Delta format so that you can see the clear difference. What happens when you write in CSV or Parquet and what happens when you write it in Delta format. Okay, so let's go and save the output in Parquet format first of all. So dataframe.write, override the existing files. Let's go and format as Parquet. So we would like to write the output in Parquet format, and this is the location of the file, in my volume. Then you can also see there is a clause called partition by clause vendor ID. So what this will do, instead of writing everything in one single folder, it will create multiple folders. In fact, it will create subfolders for each vendor ID. So if I have 10 vendor IDs, it will create 10 folders. So vendor ID 1 data will go into first folder, vendor ID 2 data will go into a second folder, and so on. Okay, so what you see is that we have got dataframe.write mode as overwrite. When we say partition by vendor ID, so there will be one partition create or one folder created for each vendor ID. Okay, let's go and run this and we'll verify what happens here. Now, while this is running, we'll check the output. Oh, it's already done. Now, along with that, let's see how we have seen how to write the data in Parquet format. So we define format as Parquet. Let's see how do we write it in Delta format. Okay, now notice here the command is exactly the same. Only difference, in fact, command is very much similar. The only difference is this time we are saying instead of format as Parquet, we are saying format as Delta. Okay, very simple, very straightforward. So instead of saying format as Parquet, see, instead of saying format as Parquet, we're now saying format as Delta. This means that now the output will be written again to data lake, but the output files will be in Parquet format, plus there will be an entry in transaction. There will be a transaction log entry. Okay, I hope everybody is clear with this concept. So writing to Parquet will write the Parquet files. Writing to Delta, it's going to write partition files, and it's going to write basically entry into transaction log. Okay, let's go and cross check. In fact, everything is mentioned here. So when you're doing hands-on, make sure you go and check out the Parquet folder, Delta folder, and every instruction is there. So when you're doing hands-on, make sure you check it out. So let me take you to catalog here. All right, so there in the catalog, let me go to data files. So this is where we have the output folder. Let's go to that. Now, once we get into output folder, you can see two folders here, one for Parquet. So this is the old folder that we created in the, in the first hour of the session. And now we have two folders created, Parquet folder, Delta folder. Let's open Parquet folder. So what do we have here? In Parquet folder, you can see there is one folder created per vendor. When you see this, some strange looking thing, this is like, basically this is for null. Okay, so if it is null, it will say vendor ID, Hive default partition. But just understand that, we have now three folders, one for null values of vendor ID, one for vendor ID 1, one for vendor ID 2. Okay, let's go to vendor ID 1. So how many files are there? So we have got, remember this is Parquet folder. So we have three Parquet files. Notice the size, 500 KB, 500 KB, 500 KB. So we have now three files in vendor ID 1 folder of 500 KB each. Okay, now let's come over, same way we have vendor ID 2 folder, and we'll see three more files here with 2.39 MB each, approximately 2.38, 2.39, 2.27. Now let's go and check the Delta folder, okay, and see what is the similarity, what is the difference. So let's go to Delta. Again, you can see there are three folders created, vendor ID 1, 2, and for null. Let's open vendor ID 1. So what is present here? Again, three Parquet files. So remember, when you're writing the data in Delta format, it actually writes the data. In fact, it physically writes the data in Parquet format. Plus, notice the size, absolutely same. Absolutely same. There is no difference, not even 1 KB or 1 byte difference here. It is exactly the same what you saw in Parquet format. So basically what you'll notice that there are three files. Each file is exactly of the same size, as the Parquet folder. Then if we come over to, let's say, vendor ID 2, again, three files of 2.39, 3827, exactly the same size which is there. Okay, so this means there is no difference when you're writing in Parquet or in Delta format. The only difference is, if you come to Delta, you can see now there is a Delta log folder. Okay, let's say if we open up the Delta log folder, what do we expect to see? 0.json. Right? Obviously, it's not just 0.json. It's a pretty big number because you might be doing, let's say, thousands and thousands of transactions. So you can see that this is the number 0.json available in the folder. Okay, makes sense. This is the only difference we have got. Let's open this file. What do we have here? Okay, let's have a look. Do you see there is, the timestamp when the commit was made? So now we are also not just keeping the information of files, we are also keeping the statistics. When the commit happened, who is the user? Do you see user ID, username that's available? Do you see the write operation? So this means we have written the data or inserted the data. Then mode as overwrite, every single information is being locked. Okay, that is the benefit here. So partition by vendor ID. So now we know that when we were writing the data, we have the vendor ID. Vendor ID was the basically was used for partitioning the data. Okay, then we have got some other information like number of files which were written in this transaction, total 8 files. Okay, so I think 3 files in vendor ID 1 folder, 3 files in vendor ID 2 folder, and 2 files in vendor ID null folder. Okay, then you can see that number of files. Then look at the what is, we have got the schema also. So it is also maintaining, what is the schema of the files which we have stored. Okay, so we have, the name of the column, the type here, and whether it is nullable or not. So not just we have the number of files, the timestamp and everything, we also have the schema available here. Plus now it's something that we talked about. Number of, let me show you. Do you see add operation and the path of the file? See, add operation and the path of the file. So this is showing us that now this file is part of transaction. Let me show you one more. Let's see where I can find it. Obviously it's actually, I can take it out and show you, but I'm sure you will get the idea. Let me search for add. Okay, so you can see add operation. Do you see another add operation with the file path? Okay, let's scroll down. You can see another add operation. So what you will see is these are the add operations saying these basically files are now part of transaction. this is how the Delta Lake stores the information. But not just this, it also stores some very interesting things. What is that? Let's see. So this is basically add operation. What do you notice? It is having add operation and the file path. Okay. It also contains partition value. So basically, what was the partition key value? And it contains the size of the file. It contains the modification time of the file. It contains the number of records in the file. Plus, it also contains what is the minimum value of each column in the file, what is the maximum value of each column in the file. Now, think about the kind of things we can do. This means during our select queries or during our reading process, we can utilize these minimum. The Delta Lake minimizes this. In fact, Delta Lake utilizes this minimum and maximum values to help us do to read the data faster. So that is the benefit of using Delta Lake. Okay, so let me pause here for a second. Guys, quick check again. Is everybody clear with this concept of Delta Lake? Getting the idea, how Delta Lake is, when you are writing the data, it's not just writing the data, it's also storing information in transaction log. And transaction log is in front of you. uh, that you can see that we are having commit information, user information, what is the operation we have performed, what is the mode, which is the overwrite, what is the partition value, what's the schema, how many files have been written, how many number of output rows have been written as part of this transaction. Then we also have record of each and every file, plus what is the minimum value of column in each file. In fact, for a one single file, what is the minimum value of every column, what is the maximum value of every column. Lots of statistics are being updated here, because of which it will help us going to have some really interesting cool features that's going to come up here. Okay, time traveling, applying the constraints, all these things, it's going to come up here. Okay, fine, everybody clear with this concept now? Getting the idea how it's helping us store the information. So let's move forward. If everybody is clear with this concept, let's move ahead. And now that we have seen how to write the data in Delta format, now it's time for us to create, we can go and create a table on top of the data. Now I know there are a few questions coming in, but please just hold on to that. Let's quickly move forward. So now what we can also do is we have the data in we have the data in Data Lake. Okay, so you can see it here once again. We have the data available in this particular folder, greentaxis.delta. What we can also do is we can create a table on top of it. How we can create a table? Remember this concept that when you're writing the output to Data Lake as a table, so the files goes into Data Lake, but the metadata is registered with Databricks. Now I'm going to do inverse. So since we already have the files written to Data Lake, we can go and register the metadata of these files. Once again, we can register the metadata of these files in Databricks. That will become a table. Okay, so earlier we were writing the output as a table. So files were getting written to Data Lake, metadata was getting into Databricks. Now we are going to reverse this. We already have the files in Data Lake. We are now going to register the metadata of these files in Databricks. That will become a table. Okay, so let's go and check it out. So what I'm going to do, I'm going to say, I think let me drop the table if it already exists. Okay, now what we'll do, so we have written the output in Delta format. I can even go and write it as a table, or I can actually create a table on top of it. Okay, so I'm going to take the data frame again, just write it, basically write it in Delta format and save it as a table. So remember, once we are saving it as a table, metadata goes into Databricks, the files goes into Data Lake, but along with the files, the transaction log entry goes there as well. Okay, now that we have created this one, we can just we can actually look at it in the catalog. So we can come over to catalog, and we are into O'Reilly. Let's refresh it. Okay, so we are in the O'Reilly catalog. Let's open taxi.db, and there you can see green taxis table which has been created. Okay, so now that this table is created, we can run select count queries, select count star from green taxis. We can just look at how many records are there. See, 449k records are present. Then in the same way, we can start running insert, updates, and deletes. Okay, let's go and see that in 5 minutes, and then we'll do some hands-on. Okay, now here is a very interesting feature of Delta. We can look at the transaction log. I don't have to open the folder and look at the things. We can just go and run this command, describe history command. So what is this describe history command? So when you say describe history table name, this is going to go and fetch all the transaction log entries, and then it's going to show you, you know what has happened in those transaction entries. So you don't have to you don't have to go and look at each and every file manually. Once you run describe history command, you can see there is only one version right now. What, remember the timestamp when the commit was made, who made the commit, okay, what was the operation which was performed, so what was the partition key value. So you can see every single information, kind of lot of information that we have in those files that will appear here. Okay, so you can even see number of files being written, number of output rows being written, and so on. So what I would recommend you is, whenever you are working with Delta, always go and start using describe history command, whenever you are doing something, so that you can clearly see what kind of transactions are happening on the table. Okay, so that's what describe history command is all about. Now, moving on, you can go and, I'm going to leave it for you to try this out. You can overwrite a Delta folder, very easily. Then you can also go and, let's say, apply schema enforcement. Okay, so what is this schema enforcement? Remember that schema is being maintained into transaction log. Okay, so let's say I'm running this command, insert. In fact, this is, yeah. So what you will see is that I'm putting up basically some command here, and we have got a vendor ID column which is integer. I'm trying to put junk here. It's an integer column, so it is basically maintaining the schema as well, saying that I'm not going to allow you insert any junk data into this table, because the column is integer, but you're trying to insert basically string value here. So what you see is the schema enforcement is being applied on the table. Okay, so we can override the data, we can append the data, we can apply schema enforcement, and so on. Plus, we can also insert the data to Delta table by using the insert command. Okay, so I can just run this, the insert command will run, insert the data. Not just insert the data into this table, we can also go and append the data frame into the table. Okay, this means, if we have a data frame, let's say, has got 10 records or something, we can go and say, let's append the data frame into the table, which means take all the records and append it to the, append it to the table, and that it will also verify whether it has the right schema or not. Okay. Another quick question which I can see is, can we define primary key columns, unique column? Unique columns, no. You can define primary key columns, but primary key is not enforced. Any big data system or data warehousing system that you work with, the primary key, you can define it, but primary key is not enforced. So what is the purpose of defining that? Okay, if I write primary key, the underlying system will know that, okay, this column is supposed to be primary key, and they can, plan accordingly. Or even the queries can speed up when it sees a primary key, assuming the column will have unique values. But primary key is not enforced. Okay, remember, it's not a SQL Server Oracle kind of database. It's a distributed processing architecture of Spark, storing the data in data lake, and Delta Lake is providing asset guarantees. Okay, all right. So you can see how we insert the data. In the same way, we can, let's say, read another file. Okay, so I'm going to read another file here, which is append. Okay, and once we basically create a new data frame, okay, so this data frame contains only one record, we can just go and append this data frame. So take the new data frame, mode as append, which means write new records to the table. Okay, and we can say the table name. Once we run this, it will first verify the schema, that whether we have the right schema or not. If the schema is not matching, it's going to throw the error, but then it's going to write the output to data lake, or it's going to write the output to Delta Lake folder, and obviously metadata is with Databricks. Okay, so in the same way, we can perform, update. So very easy. We can run the update command, update table, set rate ID 2, vendor ID equal to 4. But the process behind the scene. Whenever we are running the update statement, a new file is created. the previous data is copied to the new file and the previous one is marked as removed. Okay, can we go and cross check that? So let's say I'm going to go and say describe history command. Okay, remember the describe history tells us about all the transaction entries. See, multiple transactions we are doing. First we created the table, then I did an insert operation, then I appended the data frame, and now we have done the update. And it also contains the information of when the update was, or what, on what basis update was performed. Lots of information is now available to you as part of Delta. Okay, do you see number of removed files? What does that mean? Number of removed files means that one file is marked as removed and a new file has been added to copy the unchanged rows. Okay, so that's how we can start looking into transaction log and see what is happening on the table. In the same way, you can perform merge. I'm going to leave it for you to try this out, because obviously it's very simple. So if you, just like in let's say other databases like SQL Server, Oracle, Snowflake, you perform merge operations. In the same way, you can perform merge operations in this one as well. Okay, so you can run merge command. So take the data from a take the new set of records and merge it into the table. So you can do insert, update, delete. All the operations can be performed. Okay, so let me stop here. Guys, do you want to start with the hands-on, play around with all these different features? There are a few more features I'll show you, but do you want to first spend some time doing this activity yourself? Quick check. You can give me a, you can write it in the chat. You can give me a thumbs up if you want to do this hands-on. Do you want to play around with these features yourself? Okay, yes, I can see few people are saying yes, we would like to do it. Okay, so let's go and start with the hands-on activity, and I would like you to spend some time, go through these steps one by one. If you have doubts, put it in the Q&A or in the chat window, and we can pick it up from there. All right, so what I would what you can do, you can go back to to the GitHub repository. From there you can download this notebook, lab number 4, working with Delta Lake. There are a few more features I'll show you, but first let's get started, do some features, and then I'll walk you through the next set of features. Okay, so lab number 4, working with Delta Lake. You can download this notebook, import it into your workspace, and then you can start running the commands one by one. Please remember, while you're running the commands, make sure to check what is happening in transaction log, check out what is how many files are getting added. So look at all these different things, and then you'll have a better idea of stuff. Okay, so let's spend around 25 minutes. Okay, so I'm just going to start the timer. All right, so let's keep it 25 minutes. So spend some time with Delta Lake and see how these things work. And meanwhile, I'm going to address all the questions which are there. And of course, if anybody has any doubts, do put that in the Q&A or in chat, and then let's discuss. Okay, so let's start by downloading this notebook from GitHub repository, which is working with deltalake.py. All the things we have discussed are available, plus a lot of additional features are there, which I would like you to run the code and check it out. Now, code running is not a big deal. Understanding that concept was important, which we have already gone through. Okay, let's have a look at some questions. One question was, can we compact, somewhat with the initials JG, can we compact transaction file? The transaction files can be compacted. In fact, it is compacted automatically. Okay, let me just mention it here. So let me just write down these pointers for you to use. Transaction log compaction. It is done automatically by a feature in Delta Lake called checkpointing. Okay, this means if you have hundreds of, somebody's saying, will you be sharing the GitHub link? Yeah, I shared that yesterday. I'll just quickly share it once again. Sorry for that. I'll just quickly share it. Okay, so this is the GitHub link I've just shared. Let me also share the link to the files. Those who have not downloaded the files yesterday, I'm just sharing the link again. Okay, so coming back to transaction log compaction, it's done by a feature called checkpointing in Delta Lake automatically. Okay, you don't have to do that. And another question, how do we get access to Azure? They have limited free session, I believe. Yes, Azure basically has, you can sign up for a free trial, but not required here. You can start with Databricks free edition. So if you're starting with Databricks free edition, in the GitHub repository, there is, there is lab number one, option number two, and lab two. So you can first do these if you are joining today. Lab one, option two, setting up a free Databricks free edition account, and then lab two, uploading the files, and then you can do lab number three, working with Spark, lab number four, working with Delta Lake. All right, and another question, this is where I'm fuzzy. When we create the table, we are still referencing to the data frame? No. When we create the table, the data goes into data lake and metadata comes into Databricks. Data frame is gone. As soon as you write the data from data frame to table, table has its own data. Data frame is basically a in-memory object. So the data will be written out to a table in the form of files. And if you close the cluster, data will still be there as a table, but data frame is gone. Okay, so your question is, are you saying that by referencing the data frame, it is essentially a pointer to the files? So once again, data frame is an in-memory structure. It's going to help us write the output to data lake. Okay, that's something we can perform. But as soon as you stop the cluster, remove the session, so data frame is gone. It's a in-memory structure. But when you write the data as a table, it's actually stored in data lake. The table is basically the metadata registered in Databricks. Okay, and another question, also these transaction histories are only for the created table, and we should not see changes to delta log JSON file. Transaction history for the created table. Yeah, so when you create a table, transaction log entry will be created. So please ensure you do not make any manual changes to the delta log folder. Okay, somebody saying there is, let me see, there's quite big questions. Another question from someone with the initials CJ. Is there any standard function method to implement SCD2 on Delta tables? Yes. So if you look at Databricks documentation, using Delta Lake, you can implement SCD type 1, type 2, even type 3, you can implement on Delta. Okay, so you have got, and the dev state, you're saying I'm a tech PO and our dev state that updates is very expensive option in Databricks. Yes. Why basically update is an expensive operation? Because you're copying the unchanged rows into a new place, and then you're going ahead and you're copying the new changes into another place and then marking the file is removed. So if you're doing very frequent updates on single records, too many files are going to get written out. Okay, or too many files are getting copied. That is why it's an expensive operation, but still you are getting that feature which you do not get with Parquet or CSV data. Okay, so yes, it's a bit of expensive operation. The SCD, we don't use Delta Lake for transactional purposes or OLTP type of storage. It's an OLAP data. It's a OLAP kind of work. Where you want to do analytics, you have lots of records, you update it at one shot. You have lots of data you inserted in one shot. That is what we do as an analytical processing. We should not use it as a transactional system. With uh, typically people don't use it for SCDs and all. But yeah, if you want to, actually you can. You can just go and use that. But yes, why it's expensive, because you're copying the data on every update. Now there are ways to optimize it, but again, that's out of the scope of our discussion for now. Okay, another question is, do we have an example or lab on how to update Delta Lake, run vacuum to clean in practice? See, update is something which you are already seeing here. If you want, I can give you the command for vacuum also. Okay, so example for update is something you are seeing in this one. We are already performing update, insert, delete, insert, delete, merge, all things we are performing. Vacuum is a very simple command, one line command, which I can give you if you want. Okay, another question is what other files generated in the Parquet folder? See, when you, let me show you. So if you get into, let's say if I'll just go over to, let's say the data files, I open up the output folder. Under output Parquet folder, you can see some files created. This is basically created by Spark, to kind of, it's like a pointer for the Spark that, okay, I have committed the changes or not. When did I start? When did I complete it? So basically, you can see it's all 0 byte. So Spark is just kind of keeping some reference dummy files for its processing to complete. That's it. Okay, just ignore these files even when you're reading through Power BI, or if you're reading this folder through Power BI, or if you are reading it through any other tool, they simply ignore these files. In fact, even if you open vendor ID 1 folder, you will see that these are the actual data files, but then these are the files like started, committed, success. This is not required. Okay. All right. So just feel free to, just ignore these files. This is Spark creating these files of started, committed, just to manage, or just to kind of keep a tab on, what is done, what is not done. But if you look at Delta folder, Delta does not have that thing, because Delta meant, you don't see any, those started success file, because there is no workaround required. Delta Lake can handle all of this. In fact, if you open vendor ID 1, no dummy files like started, committed, success, nothing is there. Okay. Then another question on how do you structure the file in such a way that the data pipeline runs on a daily basis to basically, how do you structure the file in such a way that the data pipeline runs on a daily basis to update the files? I see you're coding in the notebook, but for a bigger project, wouldn't we, uh, need to structure the scripts in such a way that it is hands off and updates at Delta Lake programmatically? Yes. See, right now, this is for the demo purpose. I'm showing you how do you actually, just let's say perform an update, look at the transaction history, open up the folder, check out everything. So this is for the development purposes. When you're into production, when you're doing the update, fine, you run the update statement. Then you also go and maybe log the describe history command, so you'll get to know what transactions are happening. Or even if you don't want to log it, fine, you can just run the update statement. Behind the scene, I've already shown you how Delta Lake will work. So in production, you don't have to run through describe history every time. You don't have to open the folder and see how many JSON files are there. No, you simply work something like this, where you can just run select couple queries. You can go and run, let's assume, let's say, the merge commands, update commands, delete commands. So you continue to work with it like you're working with a database, but then because I've shown you all these things, so that if you want to do troubleshooting, you want to do debugging, you should be able to go back and check what is happening on the table. Or if somebody complains that some wrong process has updated something, or if you want to roll back, so that is what you get from the transaction log. Okay, we don't look into the folder structure every time when we are into production. Okay, another question is, how can we rename columns in Delta table since it's not a relational table? You can go and rename columns in Delta table. Okay, so I'll not write the command, I'll show you here. So Delta table, rename column. So there is a alter table command that you can run. All right, so there we go, alter table, and then we can, in fact, you can see here, alter table, and this is the Delta table, rename column, old column to new column. Very easy. So this is all because of Delta. So in Delta table, you can go and rename the column as well. You can see that on your screen. Okay. Another question is to build a retrieval augmented generation application or RAG application, where should you store your data? I have a CSV file and I would need to convert a column to embedding and then store as a vector database. Okay. So basically what you can do, if you have the data, you can put it in volume. Let me just draw it here, or maybe I'll just put it on the slide itself. Okay, so what you can do if you are planning to build a RAG pipeline, so what you can do, you can have a volume, or you can have your data in Azure Data Lake or S3 or wherever you want to. So you can have your data files being present here. Then you can read these data files using Spark. Okay, and you can put it into, let's say, a delta table. Now delta table can be stored in a volume, it can be on ADLS and all. So basically you can store all your data chunks in this in the delta table. Then once you have the data in the you have the chunks in the delta table, you can go and put it into Databricks vector search. So Databricks also has a vector search where you can put in basically all your chunks, plus along with the chunks you can store the embeddings. Okay, so during this process you generate embeddings and you put the embeddings and chunks into your vector search, and then I'm sure you know how you can go and just build your RAG pipeline. Sounds good? So this is how you can build your RAG pipelines. So if you question was where to store your chunks and all, so you can put it in the delta table, and then you can update delta table with different chunks, delete the chunks not required, and you can, yeah, that's how you can build your pipeline. That's a typical process of building a RAG pipeline. Okay, let me know if you still have questions, but I hope you get the idea that where should we store the data. Databricks also support vector search. Let me show you. So if I go into compute, we have the option of vector search. Okay, for building your Gen AI applications or building your RAG pipelines, you can store basically information into vector search. Okay, I can see somebody has a big question saying I'm still unclear. Apologies. Nothing to apologize. Let's try to understand it once again. So question is, we created a green taxis.delta folder. Yes, let me bring it up. So we go to catalog. We have a green taxis.delta folder. Let me open it up side by side. Okay, output folder, green taxis.delta folder. Okay, which includes partitions and a delta log folder. Yes, so this is the data folders. These, the vendor ID 1 contains vendor ID, the first vendor's data files, and you can see all the Parquet files here. Then if we go to vendor ID 2, it has its own data files. So basically these folders contain Parquet files or partition files, right? Partition files in Parquet format. And delta log folder basically contains transaction log entry, right? Okay, reading further, uh, we also created a table based on an ephemeral data frame. Yes, so we took a data frame, we store the output of that data frame to data lake in delta format. Once again, so this is the data frame we have got. All right, so we would like to write the output of this data frame to data lake. So this is our data lake account or volume or whatever. Okay, so we have a data frame, we want to write the output to data lake. So what we did, we used the command dataframe.write, mode as override, format as delta. So basically, let's say data frame has got 10 records. So the 10 records were written out in multiple files here. Okay, so let's say 3 files, first file with 4 record, next with 3 record, other with 3 record. But then there will be a subfolder, okay, subfolder here, underscore delta underscore log, where information will go that total 3 files have been written with 10 records in total. Okay, and you're saying, but if I made changes to the table, data in the table is no longer in sync with data in the folder. No, you're mixing multiple things here. Data frame is a set of data, you're writing it to the folder, and then your data frame's job is done. You delete, you simply stop your cluster, your data frame is gone. But the data in the data lake is physically stored. Data frame is an in-memory structure, you know, for you to process the data. Data, when you're writing the output in delta format to data lake, in fact, whenever you're writing the output to data lake, that is physically stored. Then if you're writing in delta format, then the transaction information is also stored, but it has nothing to do with data frame. Data frame was used, it had the data, we took it out, we stored it into data lake, and then you stop the cluster, your data frame is gone. But physically data is stored into data lake as separate files along with delta log folder, which contains every transaction that has been done on this particular folder. Okay, do you get the point? Data frame is very very separate. It's a in-memory object holding the data. Data lake is the physical location, which is the file system where we are writing the output. It's not like they are always linked. No. So when you read, let's say when you want to read this folder, you can read this folder and create a new data frame. So data frame is an in-memory object holding the data for you in memory, while this is the physical storage of data in data lake. Now, is it clear, or shall I read through your further query, or if you have any follow-up questions? Is it clear? Shall I go and repeat this part again? And you're saying, are the Parquet and Delta folders essentially just backup? No, these are not backups. These are physical. This is our physical data we have stored somewhere on a file system. So think about, you open up your machine, you store a file. That's where you have physically stored your data. Anything in memory, it's going to get erased. When you stop the machine, restart the machine, your data is gone. Same concept applies here. Data frame is the in-memory structure holding the data in memory. Data lake is the place, or it's a storage space where we store the files. So when we store the files, they are physically available. Whenever we want to read it, we can read it. Data frame is an in-memory object which will go away when we restart the machine, stop the cluster. That will go away. Okay, does that now give you an idea what that they are not connected to each other? Okay, one is an in-memory object used to process the data. Other is Delta Lake is a physical storage where we store the files. Okay, so you're saying but if I update a row in my table, that does not reflect in Delta log. It does. I'll show you. So what you see is, I just went ahead, we have done the update. I ran the update statement. Okay, update, and you can see one row was affected. And you should notice here that update was the latest transaction, version number 3. Now, if I go to Delta log folder, let me show you where is it. So if I go to Delta log folder, I can let me just refresh it here. This is okay. Let me just refresh the window. Not in this one. Oh, okay. Because here we have created a new table, and we are basically putting the data in the table. Okay. So earlier we were storing the output directly to data lake. See, we wrote the output directly to data lake. Let me just bring it up here. There we go. This is what you're talking about, not this one. So the first time when you wrote the output in Delta format, we were writing at a separate location. Just notice here, when you're writing the output in Delta format, it's going into a separate location. Okay, but next time what we have done, we simply created a table. This is not referring to the same set of files. Again, we are taking the data frame, writing it to a different location altogether. Do you get the point? So first time when we were writing the output to, we wrote the output to a data lake, that's a separate part. So we took this data frame, we said, okay, let's write the output directly to data lake. So we wrote the files here. Then after that, we neglected this part. We said, okay, now let's take the same data frame. Let's go and write the output to a table. So when we are writing it to a table, the underlying files are stored somewhere else. Now, does it make sense? So this one, we left it out, after our first command. Next time when we are writing from data frame to a table, it has a separate set of files. Now we are performing update on this table. So there will be new transaction log entries getting added somewhere else. Do you want to see that location? Let me show you. Just let me know. Do you want to see that location? Okay, do you want to see where that update has gone? Okay, different destinations, you cannot put it in sync. That's something you'll not. Okay, let me show you. So we have this table, taxis db.green taxis, right? Let's open it up here. So I'm going to say taxi db.green taxis. Let's go to details. What is the location? Do you see the location? Unity catalog storage East US2. It's a totally different data lake. Okay, it's a totally different location where the data has been stored. All right, I can take you to this location. This is the location I've connected to my Unity catalog. Okay, let me just show you here. It's a different location altogether. Okay, and we can go to UC storage East US2. So I can go to my container UC storage East US2. It's a different, that's what I'm saying, kind of repeating. You can see it's a different location altogether. See tables, volumes. If I go to volumes, different volumes I have created and deleted, tables are there. And if I need to copy the exact one, I just need to copy this whole path. Okay, and I need to search. So there we go. So this is the folder. Let's open it up. Okay, do you see? Let's open Delta log folder. Do you see 4 transactions? Now this is number 3. What is the update transaction number? Update transaction number is, let me show you. Update transaction number is 3. Should be 3. Update transaction number is 3. Now do you get the idea? So table has a different location of files, and we are able to pick up the information from there, or we are storing the data at a separate location. So another question is, what is the benefit of using table over delta files and using delta files over table? Okay, please remember, you can either you can store output directly to at 2 locations, right? You can store output directly to data lake, or you can store output as a table. When you're writing the output directly to data lake, it can be in underlying files. Files can be in CSV, JSON, Parquet, or Delta format. In fact, or more formats. When you're writing the output to a table, underlying files can be in CSV, JSON, Parquet, or Delta format. But metadata is registered with Databricks. Okay. All right. So question is, I don't want my teams thinking, getting confused, thinking if they want to do both. So there is no syncing thing. If you want your teams to only write output as table, that's your guideline. Okay. So you cannot say that, some of the things we are going to write, as directly as a data lake, some things to a table. People do that, but then your teams will get used to things. They will get experience. They'll know that whether you are writing the output as a table or basically as a file. Okay, it will not get confusing because you're seeing it for the first time, or initial times. So it may look like that, but it is actually not that way. It's I've been working with it for so long. It's not at all confusing. You can store the output directly as files. You don't want metadata, fine, and store it as a there. But most of the teams, what they do, they just prefer to create tables. Nobody goes and directly write the output directly as files, because then you cannot get the metadata out of it. Okay, so that's uh, all right. Okay. Somebody saying I would just create the table and use it separate location as also the storage of. See, again, you can do that as well. Those are called as external tables. Okay. So lots of different things, but this is the first kind of time we are getting through this part of it. Take some time, and I'm sure you'll get used to that. All right, so with that, I think it's time for us to take a quick break. So we'll take a quick break of 5 minutes. After the break, we are going to start with, we have around 1.5 hours to go. So after that, we are going to start with Unity Catalog and how do we work with workflows. So remember, there are lots and lots of features available in Delta. And once you go through the notebook, you'll find all of them: schema enforcement, adding the constraints, time traveling. So all these different features are available, which you can go and utilize when you're working with delta. Okay, so let's go and take a quick break of 5 minutes. I'm going to start the timer, and I'm going to catch you in sharp 5 minutes. All right, so is everyone back? Guys, you can give me a quick thumbs up if you're in. Okay, just to quickly check if everybody is here, then we'll get started. Okay, yes, I can see few people are here. Rest all, is everybody in? Shall we continue? All right. Okay, so I hope everybody has gone through the Delta Lake notebook. So while you were going through that, so we kind of kept 25 minutes for it. I believe most of the things you have gone through. Plus, during that time, we were in a lot of discussion with few folks. We tried. We basically had. In fact, there were different types of scenarios. We tried to address that. So meanwhile, I hope you were not disturbed. You have been able to complete your own activities in Delta, using Delta Lake Notebook. Now, before we move forward, let's look at a couple of questions, or maybe two or three questions, and let's see how much you have grasped from this discussion on Delta Lake. Okay, so I'm going to push a question to all of you, and let's see how many of you can answer that. Okay, so the question is, which of the following statements describe Delta Lake? Let me tell you, these are very common kind of questions that you see in Databricks exams. So let's see how many of you can get this right. So which of the following statements describe Delta Lake? Delta Lake is an open source analytics engine. And number two, Delta Lake is an open format storage layer that delivers reliability, security, and performance. Number three, Delta Lake is an open source platform to help manage the complete machine learning lifecycle. Number four, Delta Lake is an open format storage layer that processes data. Slightly longer question, but let me tell you, these are these kind of questions you get to see in the exams. That's why I wanted to share this with you, just to kind of see how much everybody got it. Okay, so I can see few answers. Let's just give another 5 seconds. Okay, so I can see a lot of responses now. So let's go and check the answer. Okay, so more people were answering while we were discussing. So most of the people have said that Delta Lake is an open format storage layer that delivers reliability, security, and performance. Yes, absolutely right. Remember that Delta Lake layer does not process data. It basically stores data. It does not process data. Okay. All right. So if everybody is clear with this concept, so let's go and look at one more. All right. So another question is, which of the following describes the storage organization of a delta table? Which means, how does delta organizes? How does delta lake organizes the data? Okay. So first option is, delta tables are stored in a single file that contains data, history, uh, metadata, and other attributes. Second one is, delta table are stored in a single file that contains only the data stored within the table. Number three, delta tables are stored in a collection of files that contain history, metadata, and other attributes. And number four, delta tables are stored in a collection of files that contain only the data stored within the table. So how does delta organizes the data? Okay, let's take another 5 to 7 seconds. Okay, all right, so let's go and see the answer now. Yeah, more than half of the people have responded. So it's a slightly longer question. So what does it say? And everybody has said delta tables are stored in a collection of files. Yes, it's a collection of files that contain data. So we have the data being stored as partition files. We have the history, metadata, and other attributes. In fact, history and metadata being stored as a separate set of files. Okay. All right. So great one. So everybody said, shared the right answer. And let's look at one last. This one is very easy. I'm sure almost everybody can respond to it. Delta Lake uses which underlying file format for storing data? Remember, we are talking about storing data. Which file format is used to store data? JSON, Parquet, Evro, CSV. Which format is used to store data? Okay, I can see yes, as expected. A lot of people have responding to this question. More people, because it's very simple and straightforward. So, which is the underlying format being used for storing data? Okay, so let's go and see the answer. Just remember that Delta Lake does not use JSON to store the data. JSON is used to store metadata. Whenever you're storing the output, or the data is written in Parquet files, so which means your data is physically stored in Parquet files, but the metadata is stored in JSON. So question was about storing data which is stored in Parquet format. Okay, so just to clear up the any confusion, so data is stored in Parquet format, metadata is stored in JSON. Okay, sounds good, everyone. Clear about this concept? So Delta Lake is a storage layer which helps us, with reliability, security, and performance. Then we have seen that the data is stored in Parquet format. Plus, we have also looked at that, it stores multiple files, so it organizes data in multiple files, and it contains history, metadata, and other information as well. Okay, so with that, let's continue let's start with a new topic, and let me just bring it up. All right. So now let's look at what we have in Unity Catalog. Okay. So let me see. So okay. Yeah, I think there were a couple of questions. I was just looking at that. Oh, lots of people have responded in the chat as well. Okay. So good to know. All right. So let's get started with a new topic of Unity Catalog. Now, we have been talking about Unity Catalog, that Unity Catalog is used for what? For cataloging, for security, and for governance. Now, you can see the architecture once again. So remember, we have already seen how we can, do data engineering stuff, which means we have seen, we can build pipelines, do ETL activities like extracting data from sources, transforming it, and loading it into data lake. And then we have also seen that we can use Delta format to basically bring reliability to data lakes. And the actual data is stored in the underlying cloud storage. Okay. We have also looked into, the AI integration, which is available. Plus I've shown you, the AI features, some of the AI features like Genie as well, which can help you quickly, query your data in natural language. Okay. Then we also have got, we have talked about the how to set up the Spark clusters, and now it's time that we can look into Unity Catalog. Okay, so what exactly is Unity Catalog? It's basically a framework or a layer in Databricks, which is throughout the Databricks environment, where you can do security, cataloging, and governance. Let's understand what does that mean. Uh, and somebody saying, why would we want to use Databricks to build enterprise AI applications and not the big three cloud providers? See, when you're looking at the big three cloud providers, they are also, for example, if you look at Microsoft Foundry is, it's a Microsoft's one single layer where you can build AI applications. They are also getting all the uh, LLM models, or in fact, all the large language models from different vendors, from OpenAI, from Claude, from Meta. So they are also making it available on their platform and giving it to you. Databricks, for Gen AI you can also go and build that. So all those, models are also available to you from Claude, Meta, from OpenAI. These models are available. You can use that. Plus, Databricks provides us with capabilities of, in fact, Databricks started as the data and AI platform. So wherever you will look at from the very beginning, it says data and AI platform. When we, which means you can build machine learning models. Data is available at the same place. Machine learning models you can build very quickly. It has got a lot of ML capabilities. AI capabilities have also come in. So on a single platform, your data, your AI, and your machine learning models, everything sits together. That is why people use Databricks to build their AI solutions. Of course, you can use, let's say, Microsoft Foundry to build your solution. That is still not Azure. Microsoft Foundry is a separate product, which basically uses Azure to run. Databricks is a separate product which uses Azure to run. Okay, so that's what we get there. Now we'll not get into that discussion that what Databricks have over AWS in terms of AI and stuff. Maybe again during next hands-on, but it will deviate our discussion a bit. So just hold on to your questions. We can come back to it in a few minutes. Okay. All right. Coming back to Unity Catalog, you can see that Unity Catalog is one single layer which can help us with all the cataloging governance features. Let me show you, that without Unity Catalog, what happens. Okay, let's say you're not planning to use Unity Catalog. That's okay. You can still work with Databricks. Now, this means without Unity Catalog, what you will do, you will create a workspace one. So this is basically my workspace, the same in this complete environment. This is my workspace. So we create a workspace one. In workspace, we set up our compute. So we can set up, clusters and everything. Number two, we can also also define which users will have access to the workspace. And then we have basically Hive Metastore to store all the tables. Okay. So if I take you back to the workspace, all right, and come over to the catalog, you can see that there is Hive Metastore. Now, what is Hive Metastore? Hive Metastore is the place where we store the metadata of tables. Once again, Hive Metastore, it's a legacy product, where we store the metadata of the tables. So the data is stored, in basically in data lake, but the metadata is stored with Hive Metastore. Okay. Now, Hive Metastore has its own limitations. That is where Databricks call it now legacy. And what they have introduced basically Unity Catalog. So Unity Catalog is much, much bigger than Hive Metastore. So in Hive Metastore, you are only storing the metadata of tables. But in Unity Catalog, and that's called cataloging. right? So that's called cataloging, where you're storing the metadata of tables. But when we talk about Unity Catalog, we have got multiple options. We are not just dealing with, let's say, cataloging, we are also dealing with governance and security. That is why Unity Catalog, provides us with, in fact, provides us with all this security. Which user will have access to what data? You can set up row level security on a table, column level security on a table. You can set up dynamic data masking. So all these different kind of things you can set up. Okay, so now let's say without Unity Catalog, what will happen? You'll set up basically compute in a workspace, users in a workspace, and then you store all the tables in Hive Metastore, which means the metadata will be stored here, but the data, obviously the actual files will be stored in data lake. Okay, now if another team in your organization wants to work on Databricks, so they will create their own workspace. So team number two creates their own workspace. They will have their own compute, own users, and their own Hive Metastore. So what is the problem here? The problem is, if team number one, let's say team A, creates a table here called customer table. Okay, so this team has spent a lot of time and effort in building up this customer table. So once they build up this customer table, they can this table can only be utilized in workspace A. This table cannot be utilized in workspace B. Think about it again, that once you create a customer, this team number A has spent a lot of time and effort building this customer information, and you create a customer table. The team B cannot go and use it in its own workspace. Okay, because when you're working in without Unity Catalog, you are working isolated in a workspace. you know any the one team, that is whatever it is creating here, it cannot, you cannot go and access it from, or team B cannot go and access that data. Okay, so that's what happens without Unity Catalog. But with Unity Catalog, let's see what happens. Now, Unity Catalog is a single layer to do a lot of stuff. Okay, so let's say we set up Unity Catalog. This is across organization. Please remember, Unity Catalog is across organization. Now, in case of Unity Catalog, let's say you have multiple workspaces for different teams. So each team, or in fact, these workspaces are connected to Unity Catalog. Each team will have its own compute. So team one will have its own compute, team two will have its own compute. So each one will have their own compute to process the data or do analysis. Okay, so basically everybody has their own compute. On the other side, what will happen? What about user information? So user information goes into Unity Catalog. So this means now we can configure, we can give permission to users through Unity Catalog. We can decide that, okay, you have access to workspace A, you have workspace access to workspace B or not, which tables you have access to. All these things we can control centrally. Okay, so this means, and then we also have got Unity Catalog Metastore. Remember, we have Hive Metastore, which is isolated. Now we have Unity Catalog Metastore. Now what is the benefit here? So if, let's say, team number one, or team A rather, goes and creates a table, okay, let's say customer table. So if they work on a customer table and create it, this customer table will be stored in Unity Catalog Metastore. Okay, so this information is now being stored not at a central repository, but this information is now controlled centrally. Now, once we have this customer table here, now team B wants to access customer table in their own workspace, great. So they can go and get, once they get access to it, remember, Unity Catalog is also for security. So once you have this, once you provide the security on customer table to team B, they will be able to go and access this data. Guys, does that make sense? So what is the benefit of Unity Catalog Metastore? So remember, files are still being stored in data lake. It's a metastore. Okay, it's a metastore. You're storing metadata here. You're storing permissions here. So once you have, the customer table created by team one, okay, so that can be stored in Unity Catalog Metastore. And if team B, so it can be stored like this. And if team B wants to access it, they can just go and get the permissions, or they can ask for request for permissions. Once they get it, the information can be stored in, or they can access the table basically. Guys, got it? You got the concept of Unity Catalog Metastore, how you are able to now share the tables across different workspaces. Okay, then we also have centralized governance capabilities. I want to mark a column as PII data, so that if I mark it as PII, the others may not get. Let's say I can then set up policies that nobody should be able to access the columns. Even if they have access to the table, they should not be able to access the column which contain PII data. So this kind of centralized governance policies that we can set up using Unity Catalog. Okay, so with the Unity Catalog, we are able to get all this stuff. Now, let's look at the object model. We have kind of worked with this already, but what do we have in the object model? Number one, we have the meta store. Okay, now this is, just be very careful with this terminology. We have the meta store. Now, Unity Catalog meta store is not the same as Hive meta store. Please take a note. Unity Catalog meta store is not equivalent to Hive meta store. Meta store here, basically it's like a root container, and there is only one meta store or one container per region. Okay, so there is only one container per this one meta store per region, which means if your organization, let's say your teams are there in East US, your teams are there in West US, your teams are there in, for example, Central India, your teams are there in Australia East. Okay, or so basically your teams are available in different geographies. So remember, for these because they are in different geographies, there will be only one meta store per region. So we have one meta store, which is which is the East US meta store. There is a West US meta store. There is a Central India meta store. There is an Australia East meta store. Okay, get the point? So meta store is like a root container, which is attached, so basically which is one per region. Then what do we do? Once we have these different meta stores created, we attach the workspaces to these meta stores. Okay, so let's say I have got workspace one, okay, which is in, let's say it's in East US. I have got workspace two, which is in East US. I have got workspace number three, which is in, let's say, Central India. Okay, so let's say I've got three workspaces, two in East US, one in Central India. Now let's see what will happen. Now, once we have these workspaces, if we want to, and if we want to enable Unity Catalog for them, we can go and say, all right, let me attach workspace one. In fact, let me take one more example. Let's say we have one more workspace. Let's say workspace number four. This is also in East US. Okay. Now let's say, I would like to go and enable Unity Catalog so that I can take the benefit of sharing the information, sharing the data and all that. So I've got these three workspaces. Now I'm enabling workspace one for Unity Catalog by attaching it to East US Metastore. Okay, so this is the East US Metastore, which is there. Okay, so then we are attaching workspace one to East US Metastore. Then what we can also do, we can also go and attach workspace number two to the East US Metastore. Can I attach this workspace two to West US Metastore? Question for everyone. Can we attach workspace number two to West US Metastore? What do you think? Can we attach workspace two to West US Metastore? Okay, somebody is saying no. All right, so yes, those who are so no is the right answer. So remember that first of all, we have one metastore per region, and then we can only attach those workspaces to that metastore which are in the same region. So if we have got East US metastore, then we have workspace one in East US, workspace two in East US. They both can be attached to they both can be attached only to East US metastore. Okay, so there is one metastore per region, and workspaces are in different workspaces are, I have multiple workspaces in East US. Now I can attach these workspaces to East US metastore. Now, do I have to attach all the workspaces? No, I don't have to attach all the workspaces. I can say, no, I don't want to, I don't want to attach it. So if I'm not attaching it, what will happen? So if I don't attach workspace 4 to East US metastore, what will happen? It will have its own Hive metastore to store the metadata. Okay, so it will not have Unity Catalog metastore, which means any table created by workspace 4 cannot be shared with workspace 1 and 2. Once again, if I have a workspace 4 not connected to the metastore, this means any table created by workspace 4 cannot be accessed or cannot be shared with workspace 1 and workspace 2. Okay, I'm not sure the question is, can we replicate those two different region? Can you elaborate on that? I'm not clear about the question. Please elaborate, and I'll look into the question. So what you see is, if I don't attach a workspace to the metastore, then this is working in isolation. It cannot be used to send or share the tables. It cannot be used to receive any tables. Okay, so basically, it's not able to access the data available in other workspaces. But these two workspaces, workspace one and workspace two, let's say workspace one can share a table, workspace two can, basically workspace one can access that table. Okay, so workspace one is adding the, sharing the table, workspace two is accessing the table. So now they are able to share the data, but workspace 4 cannot do anything. And remember, when we have workspace 3 in central India, it can only be connected to central India metastore. It cannot be connected to any other metastore. Okay, so take a pause, see what we are doing here. First, we are creating a metastore. There is only one metastore per region for an organization. Okay, so let's say if you're in your organization, if you are working across 10 different geographies, so then you can create 10 different metastores. And once you create a metastore, any workspaces in that region can be attached to its own metastore. Workspace 3, we cannot go and attach it to West US because it's not allowed. Okay, so it can only be attached to its own metastore. Basically it can be attached to the metastore in the same region. Okay, now apart from the metastore, what else do we have? Remember, workspaces can connect to metastore in the same region only. Now, who is going to set up this metastore? Only the global admin set up the metastore. Please remember, only the global admin set up the metastore. You cannot go and set it up. Okay, somebody is saying, can workspace 1 of East US be physically accessed by user in India? Yes, that is not a problem. you know Remember that if you have got, for example, if you have workspace number 1 connected to East US metastore. Okay, so if you have a user sitting, and remember this is also East US. Okay, now if you have a user in any other geography, can it goes and access the workspace? Yes, if you give permission to the workspace, they'll have access to the workspace. But if you want to share the data between two workspaces, that can only be done, on two conditions. So if you want to share the data between two workspaces, there are two conditions. Number one, they should be in the same region. Number two, they should be connected to Unity Catalog. Okay, another question is, if we have two different teams in same organization with their workspaces in different regions in AWS. No, this is via, okay, you're saying that in the same organization with their workspaces in different regions, and team 1 wants to consume the data from tables of team 2, how can they fetch it? Now, with Unity Catalog, they anyways can't do it. Okay, so let me mention that if they are in, let me just write it like this. If there is a workspace number 2, which is in West US, all right, and you want to still access, any tables, let's say you have a table 1 here, and you know workspace 2 wants to access this table 1, they can still do it. There is something called as a delta sharing concept. Okay, so there is something called as a delta sharing concept. So you are, so I would recommend you to, if you're interested in that thing, please go and read more about it. So using delta sharing, you can share the data across the geographies. But if you are in the same region, for example, if I have workspace number 3, which is in East US, so, and if it's connected to Unity, to the metastore, they can easily go and share the data without delta sharing. Okay, got the concept? So we have, for you to share data between two workspaces, they should be in the same region. They should be connected to the metastore. Okay, 2 points to remember. So that is what is the benefit of metastore. One metastore per region. Then in the metastore, we create catalog. So I've already shown you And remember, meta stores you don't set up, it's your global admins who set it up. So you don't actually have to look at how it looks like, how to set it up. I can show you, but there is no point because it's the global admins that do that. Now, once you come over to Databricks environment, if I click on the settings icon, you can see that I'm connected to this UC-Metastore-EastUS2. So basically, my workspace is in EastUS2, and now I'm connected to a Metastore which is in EastUS2. As soon as I'm connected to this Metastore, which means Unity Catalog is enabled in my workspace. Okay, so now, so when you start, I've seen most organization, the teams get their workspaces with Metastore enabled or Unity Catalog enabled, which means admins have created the workspace, they have connected it to the Metastore. If you're interested to learn how to set it up, there are very simple tutorials available for you to do that. But since it's not, most of the people don't have to do it, I'm going to skip it through. Okay, so what you see is in the settings, Metastore is showing up. And notice here, when you see my organization, this means Unity Catalog is configured. Okay, and now this means if two workspaces are there, they can push their tables through this Metastore to each other. All right. Now, next thing is within the Metastore, once we connect to the Metastore, this is how it looks like. Now we can click on the plus sign, create a catalog. Within the catalog, we can create schema. Within the schema, we can create tables. Okay, let's have a look. So what we can do within Metastore, you can set up catalog. All right, and catalogs in same Metastore can be shared between workspaces. So if, like I said, if there are two workspaces, workspace number one has created a catalog. Okay, let's say customers data. So workspace one has a customer catalog created. All right, and now, the workspace number two being connected to the same Metastore can access this customer catalog. Okay, so what you'll see here, let's say if I come over to this part, so I have an O'Reilly catalog created. Now what I can do, I can share this O'Reilly catalog with other workspaces in the same Metastore. Okay, how do I do that? I can come over to the catalog. You can see the tab of permissions. So where are these permissions coming from? Unity catalog. Okay, so I can go over to permissions. You can see right now everybody has access to it. When I say everybody, everybody in the workspace has access to it. If you look at workspaces, okay, you see that currently only this workspace has access to this catalog, but I can say assign to another workspace. So this is like I'm going to share my catalog from my workspace one to another team which is in workspace two. Guys, you get the idea? So we have, the basically we have the catalog. We can go to workspaces and decide with which workspaces we would like to share this particular catalog. So as soon as I share it, they will be able to see this catalog, but then I can grant permission who can access the data in this. I can set up row level, column level security. All those kind of things can be done. So here I can say grant permission, and then, I would like to give them read permission, read the volume. I can give them, let's say, create function. I can give them option to, for example, let's say, execute something. So I can give them select permission. So this is how we can give permission to different users on the catalog. But then we can provide granular permissions also at the table level or at the column level. Okay. So first thing, we have the catalogs created. Within the catalog, we have got schemas created. And within the schemas, we have got the tables created. Okay. So, we have this as the catalog. We have this as the schema or the database. So this is called schema, or you can also, earlier it was called database. And then here we have the tables. Okay. And along with that, under schema, you can also create volumes. So this is where we have stored our data. So this is the volume. Okay. So it's basically a volume here. Here is the, here is the table, and we have put that under different schemas. All right, so let's come back here. So catalog is something, which we create under the Metastore, and then we can share the catalog between different workspaces. So catalogs in same Metastore can be shared between workspaces. Okay, within the catalog, we create schema, and then within the schema, we can create table, views, volumes, as well as deploy the machine learning models. Okay, that's what we have in the Unity Catalog Object Store. And then of course on each table view we can give permissions. For example, let me show you. If I go to a particular table, okay, so let's say green taxis table that we just created, so I can just click on the option of permissions, and I can say to which users I want to grant the permissions. Okay, so I can just click on grant, select a user, and give them whatever permissions I want. So this is what Unity Catalog brings to us. It talks about setting up, having a meta store where through which we can share the catalogs or the schema or the tables. Okay, and then we have all complete hierarchy. We can set up the security using permissions. Plus, we also have got other features like lineage and other stuff in. Yeah, I can show you. This is how my data is moving across different entities. So you can see that from volume we picked up a file. This is a volume, we picked up a file, and and then the data landed into a table. So whenever we are executing a notebook, it actually tracks the lineage, that from which table the data was picked up, or from which file the table was picked up, or data was picked up, in which table we have added the data. And let's say I'm putting the data further into another table, so that kind of lineage will also be captured. So this is the benefit of using, this is a quick introduction to Unity Catalog. I hope you're getting the idea that how we can, you know, how we can use Unity Catalog to share information, have central permissions, or have, set up the permissions on individual entities, how we can manage the lineage. And then there are more things we can do, like setting up, adding column masking, adding column tags. Okay, so if I want to add a PII tag or something like that, so that's something I can add here as well. Okay, so this is how we go, and basically if you want to mark a column as credit card, so basically we are getting into governance part. So I just wanted to give you a glimpse of what kind of things you can do. So governance controls, cataloging, security, right? So we talked about three things. Cataloging, you can see it here. Governance controls, you can apply tags and everything. And then we have security, which you can set up through permissions, setting up the access, set up the policies. uh, you know Governance part, you can check out the lineage and other stuff. All right, so guys, everybody clear what Unity Catalog brings to us? What are the benefits of using Unity Catalog? Just give you a quick idea about how you get started with, how do you basically get started with Unity Catalog. How do you set up a catalog, schema, tables under it, give the permissions. I just showed you the lineage also. Once you will start getting deeper into Unity Catalog, you'll see lineage. You can also look, and you can of course give the permissions. Okay, all security is handled through Unity Catalog. All right. So if yeah, I can see few people saying yes. Rest all. Is everybody okay? Any questions on this part or any doubts? Clear with this concept? Uh, at a high level, what exactly the Unity Catalog brings to us? It brings, takes us to governance or administration. So if you are into that domain, if you are interested, I would encourage you to, check out this topic of Unity Catalog, and you'll get to learn a lot more things. Okay. All right. So I can see one question. If security permission is part of Unity Catalog, where is the security in the Delta Lake? Now, again, your Delta Lake, remember, it's an open source component which still stores the data in Data Lake, but along with that, it stores some JSON files, which are basically transaction files. Now, what you see is this is green taxi. It's a Delta table. Okay. In fact, I can show you, I've got more Delta tables here, but what you see is this is, I can check actually. Let me see if I have any other tables here. Okay. So let me cross check. So let's say if I go to any other table, I can go to details and let me see what type of table it is. This is basically a Delta table. Okay. So you can see here, it's basically a Delta table. Now, since I have a Delta table, I can give permissions on this. Okay, I can just grant permission on this table to anyone. I can give permission to, in fact, I can, set up the column level, row level security. All these things I can set up on these Delta tables. All right. So this is what we get in Unity Catalog. And with that, I think it's time for us to move to another topic. Okay. So just give me a sec. Okay. I think before that, Let me quickly, let me quickly push a poll question and see how many of you got this concept. All right. So I've just shared a question saying, which of the following is not a feature of Databricks Unity Catalog? Centralized governance and access control, fine-grained permissions at the table and column level, built-in dashboard creation for visualization, data lineage tracking. So which of the following is not a feature of Unity Catalog? Okay, 20% people have answered. Let's see how many, Okay, now more. So which of the following is not a feature of Unity Catalog? Lineage tracking, built-in dashboards, built-in dashboard creation, fine-grained permission, centralized governance. Okay, so I can see a lot of people have responded. Let's go and check it out. Okay, so which is not a feature. Please remember, fine-grained permissions at the table and column level is a feature of Unity Catalog. So remember, security comes from Unity Catalog as well. We have got built-in dashboard creation for visualization. That's the right answer. That is not a feature. Unity Catalog is for cataloging, security, and governance. It is not for dashboard creation. If you want to create dashboards, there is a feature called, the AI BI dashboards. That's something you can use to build your dashboards. All right. Okay, let's move ahead to our next topic. Okay, so let's have a look at, how do we build workflows with Databricks. Now, so far we have talked about, I could see a lot of, answers in chat window also. Okay, some of them. So, and there is another question, what is the use of volume versus table? So table is where you store the data in, in Delta format or Parquet format, but it has a table structure. Volume is basically a file storage where you can store any type of file, JSON file, PDF file, backup files, audio file, video file. So in volume is a storage space. It's a file system where you can store any types of files. Table is basically, it's a tabular structure which has, it can be in CSV, Parquet, JSON, or Delta format, but then it's basically it puts the data into a tabular format. But volume is, it's a file storage to store the files. Okay. All right. So let's start with the, with this topic of building workflows with Databricks. So first of all, remember there are three types of workflows we can build. So we have got ingestion pipeline. So yesterday I showed you that we can go and build ingestion pipelines. Let me see. Okay. Uh, so yesterday we talked about the ingestion pipeline that, we can use it to ingest data from, let's say, from Snowflake, from Salesforce, from SAP, from variety of basically different data sources. So we can build the ingestion pipeline. Number two, we can also build ETL pipelines using Spark declarative pipelines, or in Databricks, it's called Lakeflow declarative pipeline. So Spark declarative pipeline is an open source project, and actually which was developed by Databricks, but now it is open source. But in Databricks, it's called Lakeflow declarative pipelines. Then we can also go and create jobs. So if we want to do orchestration, we can use jobs here. So let's start with the jobs part. This is very simple and straightforward to work with, very UI based. Very quickly, you can go and build your jobs. Okay, let's go and check it out. So what are Databricks jobs? Databricks jobs basically help us build our workflows, that can help us automate our data processing task. For example, I want to process customer data, sales data. I want to run one, let's say, customer data first. I want to process customer data first, then I want to process sales data. So this kind of workflow we can build using Databricks jobs. Okay, let me show you a diagram also. So see, this is a sample job that we can set up. For example, I want to process three entities in parallel. So first I want to process cabs information, payment type information, taxi zones information. So I want to process these three entities in parallel. Then once it is done, I want to maybe apply some if else condition. I can do I can do looping, I can do basically for loops, I can do if else condition. So basically what I'm doing here, I'm checking if the count, maybe some count value is greater than 100, then only it will go forward, otherwise it will stop. In fact, if the count value is more than 100, it will follow the true path. If the count value is false or less than 100, if it's false, then it will basically run a reporting pipeline, error reporting pipeline. Okay, so just wanted to give you a glimpse of what jobs look like through this diagram. So you can process multiple entities here. So what you see, this is called a data processing task. So which means you want to run a notebook, you want to run a pipeline. So this is called a data processing task. Okay. Then we also have got control flow task. For example, running if else condition is a control flow task. Looping through, doing a for loop, that's a control flow task. Okay. So data processing task is about running the notebook, running a pipeline, and stuff which is going to actually process the data. But control flow task, when we want to, let's say, run if else, run for loop, these are control flow. Okay. Then we have got dependencies between tasks. So you can see these are two tasks we have set up, and then there are dependency between tasks. What you see is when there is a line going from one to another, this means that tasks are going to run in sequence. So first, this dimension caps will run, then check zones count will run. Okay, so basically when you see this line getting created, so it's a dependency. This means the tasks are going to run in sequence. But if there is no dependency between tasks, they might be running in parallel. So what you see is that both of them, in fact, both of these two tasks are not connected through anything. So they are going to run in parallel. Okay. So once again, summarizing, we have data processing task, we have got control flow tasks. All right. So we have got these two options, so processing data or maybe handling the control flow. Then we have got dependencies between them. So if there is a dependency between two tasks, it's going to run in sequence. If they are not, there is no dependency, they may run in parallel. Okay. So obviously there is no dependency between the first one and the last one, but they are not running in parallel. They may run in parallel depending on what is the location of the task. Okay. Then we also have got, whenever we are running a data processing task, we also require a compute. Okay, remember that for a control flow we don't require compute, but whenever we are whenever we are running a data processing task, we require a compute. Obviously it has to, let's say if I'm running a notebook or a pipeline, it has to run on a cluster. That is why we require a compute for each data processing task. Then other thing is, once you have built this particular type of pipeline, you can go and set, you can immediately say I want to run it now, or I want to schedule it. So there are basically triggers to automate the job. Okay. So um, there is a question, can we understand these things, these similar to delta logs, where we had jobs and files created if those were successful? uh, Yeah, so I'm going to show you a demo. Basically, what will happen that, let me know if I got your question correctly. So basically, we are going to see a demo where we are going to, start processing, let's say, one entity that will be stored as a delta table. Then we are going to run the next entity, which will also be stored as a delta table. Okay, so you can see that we can run the job immediately, or we can set up schedule. We can set up, different triggers how we want to run the pipeline. All right, so these are all the different components we have got. Let's go and look at a quick demo, and I'm sure you'll get a very quickly you'll get the idea how we can actually go and build these Databricks jobs. So let's say we come over back to our workspace. In the workspace, you can see there is an option of jobs and pipelines. Okay, so you can see jobs and pipelines. We can build an ingestion pipeline, which I showed you yesterday. We can build an ETL pipeline, and we can build a job. Okay, so we are not getting into the ingestion pipeline, but let's go and have a look at the job. Okay, let me go to job here, and now we can go and start building our workflow. Okay, but before I show you this workflow, let me show you, the two notebooks we are going to run as part of this job. Okay, so first let me go back to workspace. I'll quickly bring up, the notebooks that we are going to put it in the job. Just a second. So let me just go and get to the right folder, and let me show you what. And this is the same thing, or this activity is also there in the hands-on. In fact, it's there on GitHub. All the files are also there. In fact, all the instructions are there also. So you can just go and you know you can go and follow that and complete complete this part as well. So what you see is that I've got two notebooks here. Let me go to the first one, taxi zones, and somebody with initials, with the initial U. Uh, Please correct me if, or let me know if I got your query right, or if you still have doubts. Let me know. So what we are doing in this notebook, we are setting up, the source folder. So I can run everything locally and test if everything is working fine. So I'm using the catalog, O'Reilly catalog here, setting up, the variables, same thing which we have learned, from yesterday, that we were doing the ETL activity. Okay, so we are going to define the schema. All right, so we'll create a schema. We'll basically read the file like spark.read.csv, pass in the file path. This is the path of the volume from where we are going to read the files. Then once done, we are going to create a table, or in fact, we are going to create a database and save the data frame output as a table. Okay, very simple notebook, very simple activities we are doing. Let me show you one more notebook, green taxi rides. So same process, first we are, let's say, setting up the catalog. Then we are going ahead and basically creating the schema. Actually, I've copied the code from the same notebook, which we have been using from yesterday. So you can see we are creating the schema. Then we are going ahead and reading the file again, by applying the schema here. See, spark.read.csv schema, that's something we are manually supplying. Okay. Then we are also going ahead and cleaning up the data. So again, the same clauses, na.drop, na.fill, then we are going to do drop duplicates. Okay, then we transform the data by, having a select method, with column renamed method. We have the with column for basically creating a derived column. So you can see the same activity we are performing here. And then once done, we are going to write the output, to data lake as a Spark table. So which means the underlying files will go into data lake, and the table will be registered in Databricks in Delta format. Okay, so this is what I have in the two notebooks. Now let's see how do we run it in production, or how do we basically automate this execution. So this is where, let's go back to jobs and pipelines. All right, and let's go and click on job to basically create a new jobs pipeline. Okay, let's have some space for, more space for us. Now, what we're going to do, we are going to start defining. Let me first close this. So now we are going to define the tasks here. So what I'm going to do, I'm going to click on add another task type or notebook. So you can see notebook is the most common type of task being used, which means notebook execution is the most common task. Or we can click on add another task type. So what we get here, we have the option of adding the ingestion pipeline here. So let's say if you want to copy the data, obviously for copying activity, you need an ingestion pipeline. Fine. You can build the ingestion pipeline and then add it as a task here. Once again, you can separately build an ingestion pipeline, and you can manually execute it also. But when you want to program it, automatically execute it as part of your workflow, so you come over to the jobs, add this ingestion pipeline as one of the steps in your workflow. Okay. Apart from this one, we can run. So these are data processing tasks, right? Running a notebook, running a Python script, running a SQL query, then running a SQL file, which might contain multiple SQL queries. Then we also have got, ingestion and transformation. So if you want to add the ingestion, pipeline here, for running, you can do it. If you want to add the ETL pipeline here, which you can create from Spark declarative pipelines, you can add it. So you can see a lot of ingestion and transformation tasks which are available here. These are all data processing tasks. Then we also have the option of saying run another job. Okay, so running another job means if you have two jobs, let's say a master job, and you have some lot of child jobs, so you can say, okay, create a master job and call the child jobs from there. Then we have control flow tasks also, like if else condition, for each loop. Okay, so these are basically the control flow tasks. We can also go and basically execute a Python wheel code, or execute a jar file. That's something we can do. And then if you want to refresh your Power BI reports, so for example, if we are building up a workflow and we would like to go after our workflow is complete, we would like to go and refresh the Power BI report. That's something, that task we can add it here as well. Okay, so this means that once my data processing is complete, I would like to invoke the refresh activity of Power BI so that the user reports can be refreshed. Okay, so I've just shown you all the different types of tasks which are available. Of course, some of them are not as much used, but yeah, you can see that most of the tasks are very simple to understand. So let's get started with the notebook task. Okay, so I'm selecting notebook. Now this is how the first task is coming up. We need to fill up the details and then we can click on create task. Okay, let's say I would like to run taxi zones task. So first we would like to process taxi zones. Okay, then the type is notebook. We have already selected it. What is the path of the notebook? Let's define. So I'm going to quickly select it from here. Let me see if I can. Okay, so I need to go over to, yeah, I already have that. So I'm going to select taxi zones here, confirm it. So this is how I've just selected taxi zones, the notebook. Plus, which compute, remember, every data processing task requires basically compute. So what you see is I'm selecting serverless option here, or I can even select my all-purpose cluster, which is the demo cluster. Okay, so we have got the option of choosing the compute which we want. Then once done, there are many other things like defining parameters. If you are parameterizing your notebooks, you can use it. If you want to set up the notification for this task saying the task completed, task failed. Okay, so all these things you can set up here. Let's say if I click on notifications, I can add a email notification. I can put the information on Teams, Slack, WhatsApp. So I think WhatsApp, I'm not sure if it's supported, but Teams, Slack, we can go and put the notifications there. All right, so then we have got option of retries, how many times we want to retry in case it fails. So you can see very common things, and very easy on the UI part to we can create it. So let's click on create task, and now you'll see the task is ready. Let me go and add one more task. Okay, so I'm add more task and one more notebook task. Because there were only two tasks, it automatically connected it. It's, but if we want to change it, we can change it. Let me just start from scratch, saying these are the two tasks we have got. Okay, so one is taxi zones task we have provisioned. Now I'm going to create one more. Let's give it a name again. See, task name here. Let's call it, green taxis task. Then once again, I can select the notebook. Okay, so let me select the green taxi rides notebook. And again, I can select either serverless option, or I can select my own, my pre-provision cluster. Then again, the same stuff, parameters, notifications, and everything. Plus, I can even define dependency between these two tasks. For example, I'll click on create task. So now we have got two tasks which are going to run in parallel. But if we have any dependency, for example, if we have, let's say, we are going to do some join to this, in the green taxis, if I'm going to join with taxi zones, there is a dependency. So what should we do here? We can go and, we can go to the green taxis task. You can see there is an option of depends on. So select all the dependencies on which it is, or select all the tasks on which it is dependent. So what we can do, we can select the option taxi zones task here, and now you can see that it has been connected. If you want, we can, let's say if you're setting up if else, you can also say true path, false path. Let's say if the condition is true, do this. If condition is false, do that. Okay, so this is how we can start creating. In fact, I can also show that to you. Add task, and I can say if else condition. First I need to save this one, it's not yet saved. Okay, click on add task. I can select the option of if else condition. All right, and there you can notice. So first we can define our condition here. So type is if else, define the condition. Okay, very easy to do. If you want to parameterize, you can also do it. All right, then apart from that one, we can say true and false condition. So let's see how do we add it. So let's say if I'm, so if we want, I can just add a task here connected to true, or I can add a task here connected to false path. of the of this particular task. So this is how we go and basically we go and create our different tasks, connect to each other. So build your individual task and then start adding it as part of the pipeline, or basically start connecting it in the pipeline. Now, once it is done, we have got many other configuration options. For example, we can set up the schedules and triggers. So if you want to run the job every day at 9 p.m. or run it every day, let's say you want to run it every 2 hours. So you can say, let me add a trigger. So you can have a schedule trigger. So run things on a schedule. You can have a file, you can have a table update trigger. So if the table gets updated, immediately this job is triggered. Okay, so if you want to continuously run it, you can also continuously run the job. There is file arrival option. So if a file is placed into some storage, for example, if you put up a file, add a new file into volume, we would like this job to automatically trigger. Think about how does the data pipelines run. Let's say somebody from the upstream team, they're going to create a file, dump it into some folder, and when they dump it into the folder, then you want the pipeline to start. And that's what you can do by using this file arrival trigger. Okay, then we have got a lot of other options like setting up job notifications. So just like task notifications, I can say that when the job starts, when the job ends, send me an email. Okay, you can also go and connect all these different notebooks we are using to a Git repository, or in fact you can set up the Git, and then we will only pull the notebooks from the Git which are committed. Okay, so then we have the permissions. So rest of the things are very much the same. Now we can click on run now, and then it's going to basically run the complete job. It will start, and you don't see it here because these are the set of tasks. Let's go to runs, and there you can see one job has started. It's already showing, it's in the running state. Okay, let's say if we click on it, now we can see each and every task getting executed. If I click on any of the tasks, it will take me to the notebook. Plus, it will even show each and every cell that has been executed. Okay, do you see that? That each and every cell that is getting executed. So if you are, see, I'm basically printing the schema. So print schema has also been logged. So this is how we can start building our workflows, our pipelines. Add more and more tasks to it. Define the notifications, retries you want to do. If you want to, let's say, apply if-else conditions for each loop, refresh a Power BI report. So all these different things you can perform, using the jobs. Okay, a quick check: is everybody okay with this concept of jobs? Very UI based, very easy to build. So if you have worked with things like Data Factory or SSIS or Informatica, so basically follows the same kind of guidelines or same kind of process. You drag and drop things and you start building your workflows. Quick check: is everybody okay? You can give me a thumbs up if you have understood this concept, or if you have any doubts, do let me know in the chat, and we can pick it up from there. Okay, somebody's saying this is really cool. Yes. So jobs are very interesting, very easy to build. What is the good part here? Let me add, a couple of things from my experience. What is the good part here? The good part is you are still into the Databricks environment. So your notebooks are there, your ETL pipelines are running, your ingestion can happen here. You can also build your, let's say AI ML solutions. You want to retrain your models. All these different things you can perform in the same environment. And once you're moving the data through your ETL pipelines or your workflows, remember the lineage is also getting logged into Unity Catalog. Then you can set up permissions on. So once your jobs are running, tables are created, you can set up the permissions also in the same environment. Everything happening within the same environment. That's the benefit of using jobs. Earlier a lot of people have you still use Databricks, and I really love that product. But the thing is, when you're working in one environment, you may prefer to use the same tools to build your to basically orchestrate everything. Okay, so with that, I think it's time. Let me ask you one question, and let me start the pulse check. So the basically question is: would you like to see another topic, or would you like to do hands-on? We have around 25 minutes to go. Would you like to see another topic, or would you like me to walk you through? In fact, would you like so another topic? You can raise a thumb. If you want to do hands-on, you can just do a thumbs down. That does not mean that that's not right, but thumbs up if you want to see another topic, or if you want to do hands-on, you know, you can select the other option. Okay, so far everybody is saying, want to see another topic. Let's just wait for others to reply as well. And it'll be, it's going to be quick, but I'll tell you, it's one of the most interesting, very interesting topics or features that you're going to see here. Okay, all right, so let's go and see. I can see a lot of people saying that, and most of them have responded with yes, they want to see it. I'm stopping the pulse check. Let's quickly go and look at one more topic here. So first, let me show you that, what exactly it is and why do we need it. Let's say, let me spend around 5-7 minutes to explain, why do we need it. So now we can also build declarative pipelines, which is by through these Spark declarative pipelines, we can build it in Databricks. Let's first see that, why do we need it. Okay, now before we go there, let's look at, a medallion architecture. Now I'm sure some of you will already be knowing it. uh, Somebody saying, please do answer my questions. I have few unanswered, still unanswered. Okay, there are a lot of questions. We'll try and answer, do our best to complete it. Or feel free to connect with me. I'll help you with whatever questions you have. Okay, so let's look at, the medallion architecture. Now, in medallion architecture, what happens is we have got multiple layers. For example, we have a bronze layer. Now, what is bronze layer? This is where we basically store all the raw data. Okay, think about, bronze layer like a folder. Let's say if you're, in a data lake, I can create a folder called bronze folder or raw folder, where we are going to store all the data we have extracted from different sources. All right, so we basically get the data from different sources and put it into a bronze folder or raw folder. Okay, then we have, once we have the data in the bronze folder or the raw folder, then we have another layer, or think of this like another folder called silver folder. So what do we do in this? This is where we keep the cleaned and transformed data. So this means that once we have the raw data, for example, we get a file from some source, customers.csv. Now we have extracted data from customers.csv, we have cleaned it up, we have transformed it. So the final output of it, we are writing into the silver folder. So the same ETL pipeline that I've shown, that we have built yesterday, where we read the data, analyzed it, cleaned it, transformed it, and wrote it to data lake. That is what we are going to do here. But that is what we do here. Read from bronze, clean, transform, and write it to silver. Okay. Then we have got, the gold layer. So, where we put the domain specific data. For example, in silver layer, we have got customer information, but then for marketing team requires phone numbers, but finance team does not require phone numbers. So maybe, I'll have a customer table here. Okay, so what I'll do, I'll create two folders here, one for, let's say, one for finance, one for let's say marketing. So I'll create two folders. Then create another, let's say, customer table here with, along with the, let's say, without phone numbers. And then we have one more customer table created here, basically with phone numbers. So the point is that in gold layer, we store the data which is required by different departments or different domains. Okay, so that's what we have in the medallion architecture. Now, when we want to build an ETL pipeline, it looks very easy. So we have a bronze layer, silver layer, gold layer, we still push the data and everything looks, happy to go. But then, so this pipeline looks very simple. We are talking about one entity, customer entity, but that is not practical. In practicality, we have got, lots and lots of entities which we need to handle. So we have got customers, we have, say, let's say I'm taking, common entities, customers, sales, accounts, we have got so many different entities which are there. So what you see is we have to handle hundreds of entities. We have two products, we have product categories. So we have so many different entities we need to handle. Plus, this information goes into silver layer, and there are even more entities there, because now we take the data, we segregate out things into different entities. So basically, now we have lots and lots of tables or files to handle. Okay, so think about, here we have so many different tables getting created. This will be delta tables that we are creating and storing the data there. Okay, but then, so this means so many entities here. But then once we go to the gold layer, it can become even more complex. So I might have one single customer table in silver, but now when I'm giving it to finance, it's a different table structure. When I'm giving it to say, let's say marketing, it's a different table structure. Okay. So what you see is that building ETL pipelines is not so simple and straightforward. But handling multiple entities is not the only problem. So what other problems we have? You know, so handling entities is okay. We still have entities, we'll build it, but there are many other things that data engineers or ETL developers have to do. So they have to think about how to handle the infrastructure. We have to set up right size clusters. Yesterday we discussed about the clusters. We have to set up the right size clusters. We have to set up auto scaling. We have to handle the cost. So we have to think about all these things. Plus, as a data engineer or ETL developers, we have to think about how do we manage the dependencies. So in the previous example I showed you, that first, in the previous Databricks workflow demo, I showed you that first we are loading taxi zones, then we are loading taxi rides. So we have to also manage the dependencies, because the dependencies are not properly managed, then our pipelines are going to cause problems. Then we also have to track the lineage. We have to handle the batch as well as the streaming data. Okay, so sometimes we have batch data, sometimes we have streaming data. Then the most important part, we also have to ensure data quality. This is the most important thing, because whatever data we are handling, we have to ensure that we have the data is of right quality, no junk records goes in. We are able to properly generate the metrics, how many incorrect rows are there. So we have to basically ensure data quality as well. Then apart from this one, pipelines can fail. Or maybe I have loaded a table, it was not fully loaded, I want to reload it. Or maybe I have received another file, I want to reload a table. So basically we have to handle the failures as well as the retries. Then we have to, once it goes into production, we have to monitor the pipelines, optimize them as well, because that's what, it's a part of our job. And then we also have to deploy the pipelines from development to pre-production to production, UAT and production. So we have to take our pipelines to multiple, environments. So you can see that handling one entity is one thing, or handling multiple entities is that's challenging. But then apart from that, there are so many different things we have to take care of. This is where we have got Lakeflow declarative pipelines or Spark declarative pipelines. The whatever problems that I've shared with you, many of those problems, I would say almost all the problems, can be resolved using Spark declarative pipelines without needing to do too much stuff. Okay, so it's basically a framework which was built by Databricks. Earlier it was called as Delta Live Tables. Now it's modifications have been done. It's called Lakeflow declarative pipelines. Okay, so it's a framework to build the automated pipelines or declarative ETL pipelines. Then it was built by Databricks, but now it's open source. Okay, so let's go and see how do we work with Lakeflow declarative pipelines. Okay, so I'm going to show you a quick demo, and I'm sure you're going to like that. Okay, so coming back to Workspace, let's go to the home page. Now, if we want to build the SDP Spark declarative pipelines, we need to go to Jobs and Pipelines. So we have already seen how jobs look like. In Teshin, I have given you a brief overview of that. But now let's focus on building ETL pipeline. And remember, Spark declarative pipelines can only be built using SQL and Python. No Scala, no R. Okay, let's go and see how do we do. How do we build it? So first, once I click on it, it's asking me the name of the pipeline. Let's call it, O'Reilly, let's say SDP or pipeline. Okay, so we are going to call it O'Reilly Spark Declarative Pipeline, or let me just say, yeah, O'Reilly SDP. Now, first thing, notice what it is asking us, that once you're trying to build the pipeline, please provide the catalog and schema where you want to put your tables. Do you want to put it in other place later on? You can do that, but by default, let's go and select the catalog and schema, because tomorrow when we are getting in things into production, I don't want to hard code the names of catalog and schema. Let me go and just select it here, and once I'm moving the pipeline to production, I can very easily change the catalog and schema names. Okay, so let's say I'm just going to select O'Reilly catalog. Schema wise, I'm going to use, let's say, rides. Okay, so this is how I've just specified the catalog and schema on the top of the pipeline. And when I'm moving things into different environments, I can change it also. Then I can start with some sample code, but I'm going to add existing files into it. And I'll show you each and every file. You'll see how simple it is. Okay. So once I click on add existing source code, let me bring up my folder. Okay. I'm just going to quickly, just select the folder location. So here I have a folder, Lakeflow Declarative Pipeline. I've got some files here. 6 files are there. I'm going to select it. Okay. And let me just quickly select it once again. All right, so now that I've selected the source code, let's click on add. And this would mean now as part of the pipeline, I've put up some existing code files. Let me show you what do we have in these code files. Okay. So first of all, let me click on taxi zones bronze. So I'm creating a bronze folder, or I'm creating a bronze table for taxi zone. So we are going to deal with 2 entities here as part of this small demo. One taxi zones, other yellow taxis. And then for taxi zones, we're going to create a bronze table and a silver table. For yellow taxis, we're going to create a bronze table, silver table, and multiple gold tables. Okay. Now think about it. We are now talking about 6 different entities or 6 different tables to manage. Okay. Let's look at the taxi zones bronze. So here what we are doing, we are saying let's create a materialized view. Obviously, it's like a table where the data will be persisted. So let's create a materialized view with the name taxi zones underscore bronze. Okay, let me just stop here for a second. Guys, do you get the idea? What are the challenges we face with developing ETL pipelines? Number one. Number two, what exactly is the Lakeflow Declarative Pipeline Framework? It was developed by Databricks. Now it's open source. And now we are starting with it. So we have just went ahead, created an ETL pipeline and connected our source code to it. Okay. Let me just hold on for a second. Is everybody okay with this part? You can give me a quick thumbs up if you have understood this part, so that I can show you the next steps. Just to make sure, step by step, is everybody able to understand this concept? All right, sounds good. Understandable. What is the purpose of this Lakeflow declarative pipelines? To help us quickly build ETL solutions. Okay. All right. So thank you. And I can see a lot of people said yes. Let's move ahead. Now, once we come over to the bronze, okay, and just give me a second. Okay. Now, once we come over to the bronze, we are creating a table, materialized view for basically persisting the information. We are also putting a comment on the table that it's a live, it's basically a bronze table. And now we are saying, let's go and define, basically the source from which we are going to get the data. Now, notice the interesting part. Every time we are going to run this code, is it going to create a new view? No. Or is it going to fail? No. So even if we run this hundreds of times, this create materialized view statement will work. No problem with that. Okay, this is not how we regularly work with SQL, because if the table already exists, it will throw an error. But here we are saying create materialized view, select star from this particular folder path. So what we are doing here, we are saying there is a file located, in our volume, taxizones.parquet. So we would like to read this file, which is in Parquet format. And then since Parquet already contains schema, so the schema of the view will be or schema of this materialized view will be the same as coming from Parquet. Simple. So running this one here, actually, you can see there is no option to run it because you cannot run it like this. Number two, let's go to silver. Okay. So what you see is, again, we are creating a materialized view called taxi zone silver, putting up a comment and saying as select star from taxi zones underscore bronze. So what I'm trying to show you is, first, we are reading the data. So here we have some, let's say, here we have some kind of files. Okay, so here we have a file. So what we are doing, we are creating a bronze table by reading data from the file, and we are going to create a, let's say, silver table by reading data from bronze. So creating a silver table, so create materialized view, taxi zone silver, select star from taxi zones underscore bronze. So we are now going to read from bronze, put it to silver. But then if you want to, let's say, apply a where clause, group by, join, any kind of expression, you can do that here itself. Okay, so but this is, I'm going to keep this one simple, but notice a very interesting feature which is called adding a constraint. This is the built-in data quality feature we have in declarative pipelines. So what we are saying here, that let's apply a constraint, valid location ID. We are expecting that location ID should not be null and it should be greater than 0. If the location ID does not follow, or if this criteria is not met, then on violation, which means if this criteria is not met, drop the record. Okay, so if I'm getting 1 million records, any records which are not matching this condition, drop those records. See, there is a built-in data quality check we are applying here, that if the condition is not matching, if the row is not according to this condition, just drop that record. Easy. Then let's go into the yellow taxis bronze. Okay, so bronze table, again, we are creating a materialized view, defining the column names and data types. And then we are saying partitioned by vendor ID. So you have seen that, we can we can store the data in separate folders, of vendor ID. Then we are saying, okay, let's go and select star from this location, which is again another folder which contains yellow taxis files. So let's go and read all the records. We can apply some additional columns like current timestamp and all. Okay, so everything is defined. So we are going to read the data from another file and create yellow taxis underscore bronze. Now look at what we are going to do in silver. Okay, once we come over to the silver, again creating a materialized view, adding some auto-generated columns. Okay, so as part of my table, I'm adding some auto-generated columns. So whatever value will come in pickup time, we'll take that pickup time, get the year value, month value, day value out of it. Okay, then we are also going ahead and saying select limited columns from bronze. Now I'm not reading all the columns. I'm only reading those columns which I require. And then I can drop, if you want, you can drop the duplicates, replay, remove the null values, fill the missing values, all these different things you can perform in your SQL queries or even in Python. Okay, but then notice how I'm defining another set of constraints. So valid total amount. So total amount is not null and should be greater than 0. If it is condition is not met, on violation drop the row. Then valid trip distance, violation drop the row. But if valid ride ID, if this condition is not met, on violation fail the update. So ride ID is a unique key. If this condition is not met, drop, just fail the whole process. Okay, so on one side we have the option of dropping the record. On other side we have the option of simply failing the job if this condition is not met. Okay, so you can see how we are defining our constraints, along with the table definition. So we don't have to write code separately, because if we are using multiple pipelines to write the data to the table, there is a problem, because now you have to think about handling each and every pipeline separately. But in this case, we are just going ahead and defining constraints within our pipeline. In the same way, now we are creating gold, table gold one, where we are doing some group by operations by reading data from taxi zone silver. Then we are going into another gold 2 table, but this time notice what we are going to do. We are going to join the yellow taxi silver table with taxi zone silver table. So now we are also doing the joins between the tables. So we are doing the joins, we are doing the group by operations, we are going ahead and reading from different tables. We are also going ahead and applying the data quality checks or constraints, and we are reading from the source. Now let me show you how this runs. Okay, now that we have all these things prepared, let me go and say let's connect to the connect to a cluster. So here I'm connecting to serverless. Once the serverless starts, because that is very quick, once the serverless starts, I can do two things. I can basically do a dry run. Dry run would mean that, okay, just go and scan everything and see if everything is fine or not. But just because the time is short, I'm going to, actually it's the same thing. It's just going to analyze the code and see whether everything is fine or not. But on the other side, I can say run the pipeline. Now, obviously, it will again do the analysis first, but then automatically start executing things as well. Okay, so now let's go and see what is happening behind the scenes. So I'm opening up the graph from this side. Okay, see, I'm opening up the graph from here. It is analyzing each and every file which is present in my folder and see how automatically it has find out the dependencies. Okay, so you can see how easy was it, for us to start the compute, manage the, it will automatically manage the scaling. We have already defined the, the catalog in the schema. So all the tables in this pipeline will be created in the schema. If you want to override it, you can do that. It automatically found out the dependencies also. Do you see? It automatically found out the dependencies. Even the execution is complete. So 263 records in taxi zones bronze, 263 goes into silver, 10 million records in bronze yellow taxis, 9.9 million here. Why 9.9 million? Because we have applied data quality checks. And do you see that how we are joining it? So it automatically figured out the dependencies between the two tables. Okay. So now if we want to see what is, what happened here. So for example, if I go to yellow taxi silver, okay, I can look at the data which has been stored in the materialized view. I can look at the column structure. I can even look at table metrics. You can see expectations or data quality checks, one met, two unmet. What does that mean? If we go to this, you can see that there are 99.2% records have been written to the table, 0.8% records, exactly 79,860 records have been dropped. Okay, and which condition? So trip distance, because of trip distance condition, this many number of records were dropped. Total amount, this many number of records were dropped. Obviously, total of both is not equal to this, because some records are common across these conditions. So what you see is that within just defining that this is my constraint, it automatically made sure to capture the information, show it to us, drop the records, and all the other stuff. So that's what we can perform here. Somebody saying, why is it dropped? Remember, in the constraint I have defined, okay, that I would like to drop the record. Okay, so let's say if I go to yellow taxi silver, all right, so let's look at the code. So I'm saying, I've defined the constraint here, valid total amount. This is the condition on violation, which means if condition is not met, drop the row. Make sense? So this is how, we have defined here in the code itself that we would like to drop the row here. If you don't want to drop the row, just don't put that. Okay, so this is what, guys, we can do with Spark declarative pipeline. This is just a quick introduction of, of what we have here in the framework. So with that, I think people are asking about, these notes. Let me put that in the chat window before we wrap up. Okay, and somebody is saying, how can we visualize into dashboard? Yes, that's also possible. See, this is just a quick scratching the surface of Spark declarative pipelines, and more things can be performed here. Okay, let me just quickly copy this stuff for those who are asking. Yeah, I think we are done. Okay, so I've just pasted everything in the chat window, which you can pick it up. Let me know. I think we are at the end of the session, so I think we'll just wrap it up. Please remember that GitHub repository is with you. It contains all the files as well for the building the Spark declarative pipelines, plus the other exercises that we have done. You can retry it once again and see, uh, kind of practice with it. So with that, I would first like to say thank you for joining in. I hope you had a good time learning about Databricks, in the past, in these 2 days. And I hope you like these different features which are coming, which are there with Databricks and coming from that. And yeah, please do share your feedback and let me know how things went. I know there are still, maybe a few questions which may not have been addressed. I've tried my best to, do as much as I can. Feel free to reach out to me. I'll be happy to connect, and of course, we can discuss further. So, thank you and have a wonderful day. Uh, Hope to meet you in some other session as well. Thank you and bye bye. Back to you. Back to you, Joan.
All right, perfect. Thank you so much for sharing your knowledge with us over the last 2 days. Thank you all for your participation. Just a quick reminder, this course was recorded. That recording will be emailed to you within 24 to 48 hours. And with that, we'll go ahead and wrap up today's session, and we look forward to having you join us at another O'Reilly Live course. Have a great rest of your day. Take care. Bye for now.